Fine. So fine. So I think my screen is visible, right?
Yes, sir, visible.
Okay, sure. So till now, what have we learned? Let us first see that. So till now, we have seen classes, objects, and in the last week we were introduced with inheritance. We saw when to do inheritance and when not to do inheritance. Um we also saw the Hazer relation, right? We will see Hazer relation in a much more detailed way in this particular week. Although that term Hazer relation is not used in the lectures by professor, but still we will see that the most of the content which has been discussed in the lectures is basically uh, two different implementations of the Hazer relation. So I will discuss that. Don't worry. Fine. So in this previous week, we saw inheritance and the scenarios in where to use inheritance and where not to use inheritance, and the basic motivation behind inheritance, right? Stuff like that. This week, we will see some tools, or let's say not tools, let us say see some new concepts, uh, which are based upon the previously learned concept. Okay, so these are kind of a little bit advanced topics on the ones which we understood previously. So that's why again I'm saying if you did not understand week 3, you will not understand week 4. If you have not understand week 4, subsequent weeks you will not understand, or at least not understand to a good level so that you can code something up, right? Fine. So ask questions, be interactive wherever you are facing doubt, ask that. Okay, so we have learned about subclasses. Now there is something which is called abstract classes. Now, what are abstract classes? That's the point. So let's go over here, or let me just start from the code itself. That would be a better way, I think. Is the code readable on my screen?
So you can zoom.
Zoom a little bit.
Yeah, it's good.
Okay, fine. So let us see this code at first. Okay, we will try to start the concepts a little bit later. Although this is a concept session, but I would prefer to start from the code itself. So this is a code, and I would be asking questions because this is not based upon some new concept. This is previously learned concept. So suppose I have this first class over here, supervised learning, and it has a display method which is just printing supervised learning. Then again I have a subclass which is extending the supervised learning class, and it is one of the types of supervised learning, which is, let's say, regression. Oh, by the way, let me ask, so again, for those, again have a raise of, I want to see a raise of hands who are doing MLF or already have done MLF, machine learning foundations. Either you are doing it or you have done it. Either way.
Done it, sir.
Done, sir.
Yeah, fine. Yeah. Raise your hand. Raise your hand. All of you, those who have done it, or you are, or if you are doing it, raise your hand. 5, 6, 7, 8, 9. Okay. So 8 people. That's not quite a good percentage. 27 people, 8 people. Fine. You can lower your hand. Uh, Fine. So let me just tell one thing. So for those who do not know this thing, so regression is a type of supervised learning. Okay, when you go for your MLF course, you will study these things in much more detailed way. So regression, there are multiple types of regression as well, but regression is a type of supervised learning, and clustering is a type of unsupervised learning. So as you can see over here, clustering is a type of unsupervised learning. So the question that I was planning to ask is whether this inheritance structure which you are seeing on the screen, is it correct or is it wrong? I mean, logically, does it make sense? So as I already explained it, that regression, since regression is a supervised learning, so the inheritance makes sense. I mean, although I have not written any meaningful method inside it, but still the semantics of the situation hold up. That's what I mean. So regression extends supervised learning, means regression is a supervised learning. So that is kind of correct. And same for clustering. Clustering is also is unsupervised learning. So that can extend the unsupervised learning class. Fine. So now coming back to the Java part of it. So you have these 4 classes and parent-child relationship in pairs, and each of them are printing the respective class name. Only thing is clustering has one extra method. We will come to this later on. You can just ignore that as of now. It has one extra method inside it, and k-means clustering is, let's say, one type of clustering. Practically speaking, I should not put a type of clustering inside the clustering class. It should be an object of clustering, but still I couldn't think of anything else. So just say that I have another method inside it. Okay. And as of now, let's ignore that. We will see the reason for that a little later. So as of now, just see that these 4 classes have this common display method. At least the name is common. And the inheritance hierarchy is unsupervised is parent of clustering, supervised is parent of regression. That's it. Fine. So if that is the case, now let us come to this code, the main method. So what I want to do is I want to print call the display methods. So at first I create a regression reference variable, new regression, and the object is also regression type. So basically this is child 1. So this is nothing but child 1 object, child 1 parent, reference. So object is also child 1 type, and object is of child type, and reference variable is also of child type. After that, what am I doing? I'm making a supervised learning reference variable. Okay, and then putting the regression object into it. So that is also fine, no problem. And then I am calling this system.out.println and checking if both of them are equal or not. So this is actually, I am explaining this, although this is not part of this week's content, but previous week's content where this equals method overriding was there. So I will not explain this thing now. I am just mentioning this because the code which I have posted on Discourse after the last day's session, Saturday's session, I request you guys to go through this code, run it, and try to make sense of these 4 lines. Okay, and how this works. And the other code, I have posted 2 codes on Discourse, and the other code posted on Discourse will answer this, will explain these 4 lines in a much better way. So how to modify the equals method by overriding it. Okay, so basically speaking, equal to operator will check for address value. So as long as the addresses are same, basically the objects are pointing to the same memory location. So that means they are essentially the same object, right? So as you can see in this example, O1 and O2, these 2 reference variable are pointing to the same memory location, right? So therefore the equal to will print true. But equals method works in a different manner. Equals method is a method of the object class. Object class is the superclass of all classes in Java. You know that from the previous week. So equals method is a method of the object class. Okay, and any object, therefore any object of Java, any class you create and make an object of that class, that would be able to call the equals method. Why? Because just now I said object class is a parent class of any class in Java. Any class you make or any class which is already there all those classes have a common parent class, that is object class. Now object class has in itself an equals method. So therefore equals method would be inherited into all the classes of Java. Accordingly, any object of any class you make is allowed to call the equals method. So the equals method can be called to check equality of two objects. And initially, let's say normally or usually, if you do not make any changes, the equals method will work like equal to equal to. Okay, so it will also give you true result. But you can change the implementation of the equals method by overriding it, right? So overriding of equals method is allowed, and it is obviously, since as I said now that equals method is inherited into all the classes, therefore all you have to do is just override that equals method within the class for which you want the equals to perform in a different manner. So you can override the equals method, and accordingly the equality check, the equals method whenever you do o1 dot equals o2 will perform according to the logic that you wrote inside your class. Okay, so this overriding of equals method is a very important concept, and accordingly there is another concept of overriding the toString method. So these two overriding concepts I have I have written the code for that in the second source code that I posted on Discourse. So just run them, go through them. It's not anything difficult. Just you have to see how it is important and how it helps you. Okay, just a functionality kind of idea. Fine. Now coming back to our this week's related part. Okay. Now, so please have that inheritance structure in your mind. Now we have this generic code part where we have an object. Okay. And inside an object, sorry, not object. What I mean is where we have an array of object, and we have named it to be object type. Why? Because again, object type can store any kind of instances, right? So object, generic array, and new object. This is also carrying from your previous week's concept. This has been directly discussed in the lectures by Professor. So we have created a new object array. Now this object generic, this generic array can basically store any type of object, right? Because of same reason. So now we have created the supervised learning two objects, and we have put regression of two reference variable, and we have put regression object in one of them and the parent class object in one of them. Likewise, here we have created another reference variable of the subclass itself, and we have put the subclass object inside. Same thing we have repeated for unsupervised as well. Nothing new over here, right? After that, we are storing it into the generic array that we created, just randomly storing all the objects that we have created till now, so that we cover all the cases. Reference is super type, object is child type. Reference is super type, object is super type. Reference is child type, object is child type. So all the cases we have covered, and all these three cases for both the hierarchies, that is for supervised learning hierarchy and unsupervised learning hierarchy. Now we are storing it into the object array. Right. Now the next thing that I want to do is I want to call the display method. Now display method is common, right? Display method is common in all these functions, and the signature is also same. Everything is same, right? And we know dynamic dispatch that whichever object is present, if I have overridden, then whichever object is present, that particular object's version of the method will be called in an inheritance hierarchy. And if there is no inheritance, then obviously there is no doubt. So I can call compiler will call that particular version. So within the pair, so within supervised learning and regression, obviously the objects version, whichever instance version is there, that version will be called. Likewise, for unsupervised learning and clustering as well, whichever classes objects version is there in the reference variable, that will be called, or let's say in this case in that array, in that objects array, right? Whichever version of that particular instance type is there, that one will be called. So there should not be any problem. Now, when I try to write this line obj.display, so when I try to write this line obj.display, it is giving me an error, right? Can someone predict what error will it give and what is the reason? I want you guys to think about it. Okay, so this week, as I said, you have to spend some time thinking about the code. No matter how much we explain, you have to think about it and see, okay, so there we are seeing the troubles. Okay, so this is happening here. So you have to get through these ideas, feel these things to understand. So I would take
Sir,
some
is
time.
it
Yeah,
is
go
it
ahead.
because, sir, the object class, superclass don't have any method display?
Correct, exactly. Why? Because when I'm, so as we can see, what is the motive, what is the plan, or what is my aim, right? Or what is my goal? My goal is to call the display method of all the instances stored inside the object array. So I am basically running a loop, right? Generic array, and this is this loop, right? I'm having this loop, and this obj is basically kind of an iterator which is traveling through that generic array, and it is calling the display method. Now, according to dynamic dispatch, it should work, but it is not working. The reason for that is, as correctly pointed by our friend, that obj is in this case, obj is a object type variable, or let's say object type instance, class object type instance. Now, since when I'm calling obj.display, initially the compiler will try to call the display method of what? The object class, because obj is nothing but an object type instance. Right? When it goes to the object class and sees that there is a so the overriding is happening, object class also has a method display, but somehow it is overridden. So then compiler will move the control to the runtime, as we have discussed in our last session. But at first it will try to call the display method of object class. But when it is trying to go to object class, it is seeing that display method is not there. There is no display method in object class, right? So therefore it is showing error. So there is no method present inside object class. So how to mitigate this error?
Casting, sir.
Great. Casting. So we will cast this to the particular type for which we want to call. So what should be the casting? Right? Let us go back over here. If you are not quite, you have not set up the inheritance structure, let us see that again. Supervised learning, regression, unsupervised learning, clustering. Two independent structures, parent-child structure, all of them with display method, right? So what should I cast it to?
Sir, it can't be cast to all the types. It would run into problem.
So if I cast it to supervised learning, then which two classes will work? Supervised learning and regression, right? So the parent and child type will work. If I cast it to unsupervised learning, so the display methods for clustering and unsupervised learning will work. But why for supervised learning and unsupervised learning it is not working? Although if I do not have inheritance relation between unsupervised learning class and supervised learning class, then there should be no collision, or let's say ambiguity between the functions. These are like two independent classes with two independent function with the same name, right? It's like completely two different classes which are not related to each other in any way, and they have coincidentally they have the same named functions. So in such a situation, I should not run into any trouble. Okay. But here we are still facing trouble. The reason for that is not due to any inheritance or any, let's say, any relation between the classes. Rather, the problem is that since I have to typecast my object into another type, then if I want to have this thing done under one single line, right? If I don't want to, let's say, have different loops running and different call for unsupervised and supervised learning, then I must have a relation somehow between supervised and unsupervised learning. So for that, what we can do is what should I do? I can add anything I want, or you can make any changes in the code if you feel like it. So what should I do
We
in
have to
order?
check, sir, like which instance object it is. Whose type.
Okay, so basically we can, inside this for loop, we can write two if statement, and or basically in that if else case, we can say that if it is supervised learning, if let's say obj instance of supervised learning, then call the obj.display. I mean, and the typecasting will be supervised learning. Otherwise, I will typecast it to unsupervised learning. But then again, since instance of operator only checks that particular instance type at runtime, so therefore for each case, I have to write all the possibilities. So basically, I have to write if obj instance of supervised learning, if obj instance of regression, again if obj instance of unsupervised learning, if obj instance of clustering, and accordingly I have to do the typecasting. If I am doing that, then what is the meaning of dynamic dispatch? I am basically manually making all the conversions and then calling that particular version. So there is nothing. Dynamic dispatch is not doing anything. The whole idea of dynamic dispatch is I will make a lot of stuff like this, multiple classes, multiple subclasses, tens and thousands of subclasses into an inheritance hierarchy. Here, for example, we have only taken one level of inheritance, but really, let's say there are 100 classes in an inheritance hierarchy. And then I won't have to worry which version is defined in which subclass. I will just create multiple objects and put them into an array, and then somehow I will call the array in one single line of code, and dynamic dispatch will take care of which version of the method should be called depending upon the instance type at runtime. So that was the whole point. But if I'm taking instance of five money for every case I'm writing instance of, then basically what is the dynamic dispatch doing? So that's like code redundancy. Right.
But sir, here there is a disconnect between classes, right? There is
So
no relation.
correct. So that is the point. I am telling you, you can make any changes in the code. What can you do about it? So first answer you said is we can basically use the instance of operator. I told you the problem with it. In a much larger inheritance hierarchy, that's meaningless. Okay. So how can you solve this in a much simpler and much easier way? Suppose there are 10,000 inheritance subclasses, and there are total 1 lakh independent inheritance superclass. So what I mean is, now we have supervised learning and unsupervised learning. So these are two independent superclasses. Assume we have 1 lakh such classes, and inside each of these superclasses separately, we have 10,000 subclasses. Now in such a situation, just I am basically scaling this code, scaling the skeleton structure of this code. Then can you imagine the instance of how many instance of or how many if statement you have to write? That is impossible, right? So what to do?
Look for what is common.
So what is common?
All of them have a common method called display.
Okay.
Define an interface which defines that, and then make the base classes implementing it.
Exactly. Yeah. So, but I would go a little bit slower on that, since interface is not yet discussed or we don't know.
Define a class and extend them. That's all.
Yeah, exactly. So whatever we know, we will proceed with that. So what we will do is suggest me a class name which will relate with both these two things.
Machine learning.
Machine learning. So let's say ML. So both supervised learning and unsupervised learning are types of machine learning. So you say class ML. Okay. And I do not do anything else because I don't need anything else. Other than extending them. Sorry. Yeah. What I mean is I don't have to write anything else. Extend. Yeah. So I don't have to do anything else in the ML class, right? Do I need to do anything else? No, because all I will do over here is.
No, you need to say display. It should be display.
Okay.
Otherwise, you won't be able to compile.
Okay. Exactly. Right. So that's, observe this thing. Why do I have to write this public display, public void display? The reason for that is that I have that as answered by our dear friend correctly, that we have to see the common feature between these two unrelated classes in order to do this thing. So the common feature is display. Somehow I would have to relate that. Now class ML is fine from the inheritance point of view, and then we will mention the prototype of this method, void display, right? And this is the thing. Do I need to write anything inside this display method? That's the next question. For this to work, no, right? Why? Because I mean, it's kind of an empty, because basically I don't have to do any implementation inside the display method, right? All I need is let's say a common feature to tie up these two things, so that that particular reference variable. So basically in this case, the machine learning reference variable can hold both supervised learning object and unsupervised learning object. So when I do the typecasting to ML type, obviously an ML type reference can hold any type of object. So I mean, as long as it is extended by, as long as it is supervised learning or unsupervised learning, right? So in the object array which I created over here, in the generic array, which has both unsupervised, supervised, regression, clustering, all these 4 types of object, according to the inheritance hierarchy, all of these 4 objects can be put inside a machine learning reference. So when I am typecasting this object to machine learning reference, all the types of objects which I have stored in this array in turn will get converted into the particular type, and that particular version's display will be called, right? So only thing is, we were also doing that anyway. It was working within the inheritance tree, but it was not working among the different inheritance trees, right? That is, it was working for, let's say, regression and supervised learning. Also, it was working for clustering and unsupervised learning. But for 2 independent tree structure, which was unsupervised and supervised learning, it was not working. So in order to tie them up, we created another superclass on top of that, which will just extend these 2 classes. Basically, these 2 classes will extend that superclass. And therefore, by doing that, I am getting a reference variable, and that, I mean, not variable, basically a reference type, which will be using which we will be able to do the typecasting. And once we are able to do the proper typecasting, dynamic dispatch will take care of the rest of it, right? So since that is the whole point, I do not have to define anything in the display method, right? Because our main motive is not to have an implementation or provide any, let's say, facility or any feature inside the ML classes display method. This ML classes whole function is to just tie up loose ends. That's the whole point, right? So this is the idea that we are using. Anyone has any doubt in this? Why we are doing it? Why the display method can be kept empty? Why class ML was created? If you understood properly what we have discussed in this code, interface abstract class is already done. If you have not understood, no matter how much I explain those 2 concepts, you will not understand. So please ask me doubts. These 3 questions should be clear in your head. Why I created the ML class? Was there any other way to do it? Why we created the display method? Why the display method can be kept empty? These 3 questions should be clear in your head. Ask me doubts. I will wait 2 minutes. See the code, ask me doubt. This is important.
Hello, am I audible?
Yeah,
Hello?
audible. Yep.
Sir, I'm so sorry to put up this question at this context. I mean, what is this code about? What are you, which topic are you covering? I joined really late, and if you can just briefly explain that.
So we are
would be-
starting this week's abstract class and interfaces, and this is the introduction, or let's say the motivation of why we will learn, or how the concept of abstract classes and interfaces came into existence. That's the point. Okay. So we have not yet
And
gone
sir,
into, yeah.
here we have a parent class called ML, right? So from what I've seen in the code, sir, if you can go to line number 1, please. Mm, Yeah, so there is this ML, and from ML, we have got like there's a tree structure that is happening, sir. If you just can, I'm watching from my mobile, can't see the whole code.
Okay,
So if you
fine.
can just
I will just
walk
tell,
me.
I will just briefly tell once.
Yes,
So
yes, sir.
the thing is, we have the supervised learning extends ML. Sorry, forget about ML. Assume that ML class is not there. We have this supervised learning class and the regression class. The regression class is extending supervised learning class. Again, we have unsupervised learning class and clustering class. Clustering class is extending unsupervised learning class. So basically, if I come over here, let me just state it like this. So we have this let's say unsupervised learning class, and inside and a subclass we have and supervised learning class, and here we have regression class extending it, and clustering class extending unsupervised learning class. Okay, so this is the scenario. Now all of these classes has a display method. Okay, all of them have a display method, and I have created an object array over here. Okay, object array over here, and inside that object array I have put multiple different let's say objects of different classes: unsupervised learnings object, supervised learnings objects, okay, like this, your regressions object, dot dot dot, multiple objects. And then what I'm trying to do is I am basically traversing through the array, okay, for on ARR. I'm just writing in pseudocode kind of way. We are traversing through that array, and then what I'm trying to do is, let's say we have this obj variable, or what I mean is, let me write it completely only, for obj in let's say ARR. This is not the syntax, I'm just writing it for the meaning part. So obj in ARR, we are trying to call obj.display. That's the whole point. Okay, and now I am expecting that dynamic dispatch will take care of it, right? Because whatever object is there, those will be taken care of by dynamic dispatch. But it was showing error. Why it was showing error? Because we have these two classes unrelated, and when these two classes are unrelated, since they are not part of any inheritance hierarchy, we were not able to typecast it into a specific type which will cover both of these classes, right? And that is necessary because the reference type should be such that it should cover all the specifics or all the subtypes, so that the dynamic dispatch can come into action. So in order to have this feature, what we are doing is we are basically adding a dummy kind of class, ML class, and then we are making both of them extending the ML class. That's what we did, so that we will be now able to write ML over here. And then accordingly, all these objects, dynamic dispatch will take care of which version of the display method will be called for the respective objects. So that was the whole point that we did in this code. But the understanding part of it is that, okay, so obviously in order to do that, we also had to write the display method in ML class. Okay, and we can keep the display method empty. We don't have to do anything inside this display, because basically all we are trying to do is basically have a reference variable to store both these inheritance trees into one variable. So the display method has to be mentioned so that the dynamic dispatch can work. But again, this display method does not have any specific, let's say, feature to provide or facility to provide. Unlike each of these display method, which had some specific tasks to be done, this display method is kind of just a placeholder, or just a, let's say, workaround for the dynamic dispatch to work. So therefore, we can keep it empty, and then yeah. So then after that, the things will start working, right? So my point was why we created this superclass, why we created this display method, and why we have this empty display method. These 3 points should be clear in your head. And what's more important is to ask yourself this question: was there any other way to do this? I mean, one other way was suggested, and I told the disadvantages of that. So that was not the point. So is there any other way to do this thing? That was the, so these are the realizations and the discussions that we did. Yeah, I think someone was trying to ask something. Go ahead.
Sir, previously, I mean, before adding ML part,
Okay.
so if there is a, function called display, it should work fine.
It was not working, right? I showed you on the code.
Yes, sir. That is the.
And the reason for that is what object type should you translate it? I mean, I will not repeat that since I have to discuss a lot in this session as well. So maybe rewatch the previous part of the session on YouTube, and I think I have discussed that properly. Just watch 2-3 minutes of the initial part. I think you will understand.
Okay.
Yeah. So that is mainly happening for the typecasting. So I need a type which would be super type of all these particular cases. Okay, anyone else?
Yes, sir. Hi.
Uh-huh.
Sir, I'm still struggling to understand. See, if object is a superclass for all the classes, is this was the error because of
Because the
the
object
display
class does
method
not have a display method. Yeah, that also I discussed.
Okay.
Right. So
Okay, okay, fine.
if you have the display method in object class, then it would have worked. But object class does not have a display method. So although I used object class here to have a generic behavior and store all these types of different types of object, but when I'm coming into calling the display method, then again I have to typecast the object class to some class, which has the display method, point one. Secondly, that should be a super type of all the, or let's say that should be a reference type which should be able to hold all the objects present inside the array. So there are 2 points. The reference type should be, or let's say the type to which I cast, first of all, should be 2 things. First is have display method, have a method with same signature, and point 2 is must be able to hold instances of all types present in the array. So these are the 2 points that we have to take care of.
So, sir, yeah, now it is clear, sir. But instead of declaring it object class, we can do it now ML class.
Yeah, why? Because ML class has this display method. That is the reason.
Yes. Now it is clear.
Okay. Anyone else? Everyone else understood this? Okay, fine. So if that is the case, can someone tell me if I write some implementation in the display class, maybe something system println whatever, some whatever task I'm doing, I write something inside the over here, right? I write something. It's not empty anymore. Will that make any changes in the code? Will that affect the code somehow? Will there be any corner case where this code will create trouble?
Yes, if we store the class, the object in the ML variable, then it will print that ML part only. It will not be overridden.
I did not get it. If we store the type means what?
If we declare the variable that we are storing an object, and the instantiate object, and store it in a ML class, ML object variable.
Okay. Yeah, so that is something different. What I'm telling is, will this break this code, which I have already written?
As long as all the subtypes have got that overridden, it should not create a problem.
If all the subtypes do not have
Have-
over,
If it does override, then it should not be a problem. Even if it doesn't, then it should not be a problem. Compilation should not be a problem.
Yeah.
It might miss out those subclasses.
correct. Yeah, so that was the point I wanted to discuss. But one thing, let us say if a particular subclass, not in this case anyway we said that all subclasses have the implementation. But let's say a particular subclass does not have the display method, then what happens?
It will fall back to the earlier one, whichever is the highest. Suppose if it was a multi-level
Immediate
Okay.
parent.
regression, then you have maybe lasso regression and you have some other regression, right?
Okay,
So they
yeah,
get extended. One of them did not have, whichever was the highest in that order probably will get cast into that.
correct. So in this case, let us say the regression does not have a display method, and let's say I have the first object over here,
It would
new
have gone to
regression.
supervised learning, right?
Sorry, can you repeat?
Back to supervised learning.
It will come. It will fall back to supervised learning.
Correct.
So when I
If that also didn't have, it will come back to ML.
so let me just restate this. So when I am calling the regression, this is the first object. So in the first iteration of the for loop, which display will be called? Supervised learning's display will be called, or machine learning's display will be called?
Regression. Oh, regression doesn't have.
Regression doesn't have it.
Then it will be supervised learning.
Anyone else wants to comment on that or say something about it?
Hello, am I audible?
Yeah.
Yeah, and my question is that the display methods, they all have the same signature, right? Same
Uh-huh.
parameters. All of them. I had a different question actually. So, like,
No,
is it possible to type?
I will
Okay,
come
okay,
to
sorry.
different question later. Let us answer this first. In a multi-level inheritance structure, if I have all the child classes overriding one by one, then in one level, if overriding is not there, then what happens? I mean, our friend said that it will go back to the just the next level of the hierarchy. So in this case, it will go back to the supervised learning. It will print supervised learning. Or let's say the display method for supervised learning will be printed when the object of regression is present inside this obj variable. For in this case, in case of this zero iteration, right? Zero iteration of the array. Anyone else has to say something else about it? No one,
It
right?
should
So
fall back to immediate parent.
correct. So anyway, our friend has already said, I just wanted to ask all of you guys, has any other doubt about it or not?
But sir,
So what happens is it will go to the immediate parent because that is the version which is the last updated version or last overridden version of the, let's say, inheritance tree. So first doubt students have is that they say that if a particular subclass is not implementing the code, then maybe since when I am doing this typecasting, if the display method is not there, then it might break. It might give an error. No. Why? Because this is a part of inheritance hierarchy. So since this is a child of this class, it will anyway inherit the display method, this display method, right? It will inherit this display method anyway. Now, if it is updating it by overriding, it is fine. If it is not doing it, then this display method will be called with respect to the object of the child class. Okay, but that's a completely different discussion. Anyway, that is kind of basic discussion, but still it's good to discuss that. But the main part was why we need this ML class, this display method, this concept. Okay, so now I feel that some people still have some doubt, but is this requirement of ML class part clear? You might have doubt with related to something else, that is fine, but is this okay? Because I have to proceed. So if you have doubt regarding particularly this concept, ask.
No, sir, sorry. For me, it's not clear yet. This ML part is not clear yet.
Which part?
The requirements for this ML class.
Okay, so
I mean,
yeah,
since whenever we calling the display method, it's going to be crossed by the unsupervised learning or the sorry, supervised learning classes. So why do we need the ML part there?
yeah. So that is the exact thing I discussed already. I mean, Just I would request you to watch the re-watch the session's first part. That would be easy. I think you joined little later. Any new doubt I would try to answer. I think this is again the same repetition. Otherwise, I have to repeat the same thing again and again. So, any new
No
doubt?
problem. I'll watch it. Thank you.
Ha,
Thank you.
yeah. Go ahead. So, any other doubt? Okay, fine. So now we will proceed. See, the point is now, since this display method is anyway empty and all we need, yeah.
Just a minute. I have a question.
Ha.
Last week's recording, where do I access it? It's not there in the calendar.
It should be the Java channel is there na YouTube. I think you
Thank you.
go there in I think under the live sessions tab in the YouTube channel. I think live tab, right? So YouTube live tab in the
Thank you.
channel.
I'll figure it. I'll find out. Thank you.
Okay, yeah. But now the thing is, if this is the structure, if we need such a thing, a super class or a super type kind of reference in order to address this kind of issue, right? And the display method is basically doing nothing but we need it as a placeholder without doing anything substantial within the body of the display method. We just need it as a placeholder to address the point of dynamic dispatch. So therefore, we come up with something new, a new concept which we call the abstract class. Abstract class, or before abstract class, actually abstract method. Okay, now what is abstract method? Abstract method is a method whose implementation we do not provide. So just like over here, we saw that this display method was the only task of this display method was to provide a structure so that dynamic dispatch could work, right? Provide, let's say, a workaround, or in our Hindi or let's say Indian context, as we say that a jugaad, right? So in funny way. So this is kind of a jugaad, that we are not doing something very, let's say, intelligent, only it's kind of a workaround to make the dynamic dispatch work. So therefore it was kept empty. So since it is looking kind of bad, therefore we came up with the concept of this abstract method. So such methods will not have any body. So now we will elegantly write it that public void or whatever it is, the return type display. Okay, and then we will make a semicolon. So such a method is called an abstract method, where we do not provide the implementation. And the reason for existence of such a method is the need that we just saw in the previous use case. We might come up with such a situation, and then we might need abstract methods to tie up the loose ends. That is one particular use case. There are multiple requirements, and that we will see in this week. Okay, but what are abstract classes? So any class or any class with quite usually abstract methods. So if any class has abstract method, or abstract method means one or more abstract methods, makes the class abstract. So basically, if a class has even one abstract method, you are bound to define that class as abstract. So you have to write abstract class, and then whatever is the class name. So let's say the class name is A, and then you can over here, let's say you have public void fun, abstract fun. Public abstract void fun. And then, So this is how this thing looks. Once you have an abstract method over here, you are bound to define the class as abstract. Another question is, can I have concrete methods or normal methods inside an abstract class? Yeah, you can have that. So you can have, along with all of this, you can have public normal int, let's say calculate, and it is doing something and then returning, let's say, some value. some integral value. Okay, so basically you have a body. So you can have a function which is concrete with an abstract function, and still the class will be called an abstract class. So the idea is, if you have multiple concrete methods or one concrete methods, it doesn't make any difference. As long as you have at least one abstract method in the class, that class has to be declared as abstract. If you do not, if you omit this keyword over here, Java will give you a compile time error. Okay. Now, so now, but the main idea is you can have these methods over here, but the main idea is this need, right, where this particular scenario which we discussed. So in order to do that, mainly you might not always need this abstract method, because that use case particularly required the existence of a method signature which is same as the method that are there in the subclasses. So all I need is up to this point, right? We don't need this lower part. I mean, use case requirement basis I'm saying. According to Java syntax, obviously I told you that you can have concrete methods inside an abstract class. But this is kind of all we need to tie up that loose end, right? I have a class, I have a method description inside it, which does not require any body to be provided, and therefore this is it. So since it is, we kind of developed a new kind of structure over here, class with a method where we do not have any body. So what we did is we said that, okay, let's make it a completely separate entity and let's call it interface. Interface, okay, and this basically means interface A, and inside it we will have a abstract method. Okay, so an interface are basically interfaces always have abstract methods in them. Initially, now there comes a twist over here. As I said, in case of abstract classes, you can have some concrete methods as well, and it will still be called an abstract class and it will still work properly. So what I mean is, in this example, let's say ML, along with the display, I had another method, let's say print, or let's say, print is a Java keyword, so let's use something else. So let's say output. Let's say I have another method output, okay, and it is defined. There is some lines of code inside the output method in the ML class. So will this break my structure? No, no changes will happen, because output is something that we have not used in the code, so there is no trouble with it. So although display is there, output can also be there. It can also have a body along with it. No problem with that. So that was the reason abstract classes are allowed to have concrete methods. But interfaces were not allowed to have concrete method. Okay, I said were not allowed, and there is a reason for that. As of currently, it is allowed, but forget about that. I will explain that slowly we will see it. As of now, think in this way, that we created this interface structure, and it is kind of similar to this. Okay, I'm writing both ways arrows, so that is kind of the same structure. And the reason for creation of interface also we discussed. Okay, now the idea, or if I ask you when to use an interface and when to use an abstract class from a programmer's perspective. Okay, so when should I use an abstract class, or when should I use an interface? There is a now here comes a semantic idea, a logical idea. This is not something very how should I put it, very concrete, rather a more conventional or semantic reason behind it. So interfaces basically provide specification. Okay, so these are some rules of object-oriented programming. And this is how you should do code for having a good coding practices, right? These are good coding practices. So you can use an abstract class and do a lot of stuff and do not, work along with it. But if you are providing a specification, then you should use an interface. Now, what do I mean by specification? Specification means something which does not have its own identity, but only refers to a type, or let's say something which does not have an implementation in itself, but it refers, or let's say it specifies multiple types within it. So let me give you an example. Is there any animal called mammal? No, right? Nothing, no animal is called mammal. Obviously, different animals are there who belong to the mammal category, but there are no animals which are mammal. So my question to you guys is, a class is primarily created to make what? Object out of it. That is the basic idea of OOPS. That what class is nothing but an encapsulated blueprint of the data item. And what is data item? Data item is object. So when you are creating a class, that means your primary intention is to represent the blueprint of a data item. But in this scenario, where I just created this ML type, right? My main intention was not to represent any data item, right? In fact, there is no data item. All I'm doing is tying up loose it. So here I am just specifying that there should be a display method in all the classes which is implementing, sorry, not implementing, basically all the classes which are subtype of this ML class. That's the main information that I'm trying to provide by making this class. That I have an ML class and there is a display method, and this display method should be implemented, should be there inside all the subclasses or overridden by the subclasses of the ML class. So that is all the information that I'm giving. There is no data item according to the OOPS ideology. I am not representing this ML class for, I'm not making this ML class to represent any data item, nothing like that. I was just tying up loose ends, right? So if that is the case, then ideally you should not use or create classes. You are just specifying that there should be a display method. You are not creating a blueprint of a data item, or you are not representing a real life item or data item, right? So in such a situation, you should not use classes. Class should always be used according to the object-oriented philosophy when you are representing or trying to represent a data item. So that is why I am saying these are not concrete rules. You can work around with abstract classes in place of interface, and you will run into trouble in very less situation. And very little, some situation you will run into trouble. As long as it is not something inherently Java has prescribed that this has to be implemented, this has to be done using an interface. If you are doing something like that, which we will learn in future weeks, that you have to do some task using an interface that Java has mandated you to do. If you are not doing something like that, you can actually work around by making abstract classes in specific ways according to the constraints. But you should not do that. When you are actually trying to specify a behavior and not trying to represent a data item in real world, do not use an abstract class, use an interface. Okay, and that is the reason interface names are always adjectives. And class names, as I already told you, nouns. So what is the purpose of adjective? It specifies the behavior of noun. Ram is a good boy, so that means good is basically your behavior. It is specifying that what kind of boy Ram is. So it is defining or specifying the properties of the noun. So here, likewise, interface names are therefore set. I mean, we try to keep it adjectives because it specifies the properties of the class or of the object, basically, right? So that is the philosophy behind it. Anybody has doubt in why abstract class and interface, in which situation what to use? Because this is again a good question that is asked in many software design or programming interviews, that what is the difference and in which situation one should use what, at least philosophically. So everyone understood. Okay, fine. So now, so therefore, this is the scenario. Now coming back to our previous discussion, that abstract classes were allowed to have some concrete method inside them. And I told you that interfaces, since they are specification, that means their own identity does not exist in itself. Rather, they specify the behavior of some other items. So as I said, mammal is not an animal. Mammal is a specification of what kind of animal any other type can be. So let's say cow is a mammal. So cow can serve as a noun. Sorry, not noun. Cow can serve as a class, and mammal can serve as an interface. Something like that. Okay. But practically speaking, what happens is, I would tell you, there should be a class which is a noun. So let's say numbers. Numbers is a class. Okay. And we know that we can compare between numbers, right? And we will see this comparison part in this session as well. We can compare between two numbers, which number is greater, which number is smaller. So therefore, we will have an interface, or we can have an interface called comparable. I'm using this example because it's there in the slide. So comparable. Any adjective. So you see the interface names will be some things like this: comparable, runnable, walkable, swimmable. So, I mean, which is specifying the behavior, right? And you will compare interface comparable, and inside this you will have a abstract method which will say, let's say, compare public abstract CMP. And inside this class, we have to, so our main motive was what? To have an inheritance kind of structure, right? So what we will do over here is, we will not say extends, we will say implements. Because you are implementing that specification. So class number implements comparable. Okay. And the contract is that you have to implement the CMP method over here. So which was defined. So you have to compulsorily override CMP. If you do not override, that means what? That means again you have inherited an abstract method, because this is an abstract method. So since you are implementing it, we in case of interface, we use the term implements. We do not write extend. Okay, that's the difference. So, but you can think in terms of concept. It is basically like inheritance. So it is inheriting this CMP method over here inside this class. So since it is inheriting this CMP method over here, if you are not overriding the CMP method, that means what? You are getting an abstract method inside the numbers class. So when you are not inheriting, when you are not overriding it, you definitely have to write over here abstract. Either you make the class abstract also, or you implement the abstract method which you are inheriting. That is the contract. Okay, fine. So what does this mean? This means that numbers are comparable. Numbers implement comparable means number will implement the method CMP, and then we will be able to compare between two numbers by using the CMP method, right? Because CMP will be a method of the numbers class. So when I create two objects which are basically two numbers, then I would be able to use the CMP method to compare between two numbers. So numbers are comparable. So something like that. Okay, fine. Again, now I will go back to inheritance a little bit. In Java, multiple inheritances are not allowed. What is multiple inheritance? So let's say I can have a car class. Okay, and inside this car class, I have a method public void ride. And let's say I have provided the implementation that whatever, some specifics related to car. Okay, maybe the spark plug starts or whatever, something starting from spark plug, and then some lines of code after that regarding the next steps, and then I have ended the method. So this is car class. And again, we have another class, horse class. Okay, this also has a method okay. Now obviously the implementation will be completely different, right? Because ride in case of horse will be different. Maybe you first would be sit on the saddle. Okay, stuff like that, whatever. There's some lines of code with respect to the riding of a horse. you have over here implementation. These are the two classes. Okay. Now, let's say I have another class. Now I will have a hard time finding out something which logically can serve as a child of both of these parent classes, but let us say some X class is there which satisfies
Power
the
maybe.
meaning. What?
Hot power.
Horsepower is something which is, horsepower is something that is one concept. It's not, so horsepower is not a car, right? Horsepower is a car, does not serve any English.
Yes, we measure.
What? Your voice is cutting.
So we measure a power of a engine with that, and that has something to do with horse. So
No, that's
why
not
it's
the
safe.
point. I told you, na, inheritance means you have to ask yourself this question. Horsepower is a horse. Is this statement making sense?
No.
Yeah, then you cannot have inheritance. So, okay. So anyway, so let us say this class X is there. Okay. Class X extends, somehow I need both of the features of these classes. Okay. So class X extends both horse and extends car. Now the problem is we have both of these methods, right, which are meaningful method in their own respect within their separate classes. But when I have such a feature called class X, which X is something which is, let's say, logically, which can serve as a child class of both car and horse. Okay. Okay, again, I don't know what can serve like this, but let us say something like that, which can serve as a child class of both car and horse. So in such a situation, the thing is, I will have two copies of the same signature ride method, because one part of it will be inherited from the horse class, another part of it will be inherited from the car class. In such a situation, when I create an object of the X class and call the ride method, right? So when I create this, or let's say in the main method over here, inside the main method over here, I do something like new X, right? Dot ride. Now the problem is I don't know which version of the ride method will be called. You want to ask something? Okay, I think someone is unmuted. Can you mute yourself? Oh, fine. So, yeah. So when I call this method, the compiler will not understand which version am I trying to refer to. Am I trying to refer to the one which I inherited from car or which I inherited from horse? So in such a situation, we will run into a dilemma, and therefore this is the reason why multiple inheritance is not allowed. So let me draw the structure. Don't get confused. This is not allowed. Okay. So if I have two super classes, let's say super class 1, super class 2, and I have a subclass 1. So this is what's not allowed. That is, I'm not inheriting. This is not allowed. But most definitely the other way is allowed. That is, I can have this one particular superclass 1, and from that I can have multiple subclasses. Subclass 1, right? Subclass 2. So this is fine. There is no problem with it. So this is allowed. Okay. So Java does not support multiple inheritance. That's the point. And the reason for that is also we saw. This is, by the way, is what we call later on. This translates into diamond problem in terms of other programming languages. If you see, this is a quite used term, diamond problem. That you have, why diamond? Because let's say even in a different kind of structure, let's say I have one superclass and then I have two subclasses, right, which are inheriting from this superclass. And then again, I have another subclass over here, which is inheriting from both of this superclass. I have an inheritance structure like this. So in such a situation, what happens is the things get a little bit more complex. So let's say this have a copy of a method A, right? And this A method will be copied over here as well and here as well. Now suppose over here I override it. Okay, I override the A method and let's call it A prime for understanding purpose. And but there is no difference in the signature, right? Just for understanding purpose, I'm calling it A prime. So then again, when you inherit over here, then there is A and another A, two versions of the A, but this is actually the overridden version, which is basically this classes. So this essentially brings down the same problem which we saw even with just one level of hierarchy, even with this much structure. So you have two copies, right? So once you have two copies of the same method, then you don't know which version to be called, and that's why you run into trouble, and that's why Java compiler does not allow it. But why we call this problem diamond problem? The reason for that is we have this diamond-like structure when we have one more level of class over here. Even without it, we still face it, but I just discussed it because this is a quite used term in programming, let's say, discussions. So Java does not allow, because of these reasons, multiple inheritance. Okay, fine. So if multiple inheritance is not allowed in situations like this, so coming back over here, let's say if I have can I write something like this, that class suppose Y implements A, okay, and let's say implement B. So what I mean is, can I have a class implementing two interfaces? Obviously, we just saw a class cannot inherit two classes, so that is not there. But so extending two class, extends A, extends B, obviously not allowed. But implements A, implements B, is it allowed or not allowed? That's one point. So as of now, our understanding is what? The main problem in case of classes was that we had multiple definitions, right? But in case of interface, since we do not have any method body, we only have prototypes. So even if both A and B have same prototype method, so let's say there is an interface B, and that also have a public abstract void fun, just the same like this. Okay, just imagine in place of A, B is also there. A is there, B is also there. So then will I run into trouble in class Y? No. Why? Because there is no implementation of, or there is no body of the method inside A or B. So when two copies of the same abstract method comes into Y, they are still abstract methods. Although there are two copies coming from A and B, but they are basically the same thing because they do not have a body. So there is no way to distinguish between them, right? But in this case, it was different. Since they were classes, right? Over here, since they were classes and they have very specific body, it was sitting on the saddle and stuff like that. Here it was starting the spark plug, and basically it was some meaningful lines of code. The method body was there. So that was a clash. Which version to call? Which task do you want me to do now? When you are calling the right method over here, it was getting confused. But since interfaces do not have any body, so even though we inherit multiple copies, it does not make any difference because they are basically specifications. They are empty methods. So you will not run into any problem. Therefore, multiple interface implementation is allowed in Java. Okay, no problem with that. Till this point, it's clear, right? So multiple classes cannot be extended, but multiple interfaces can be implemented. Can I extend one class and implement another interface? Something like this. Let's say in place of implements, I have something like this. Extends A. That is also correct. You can also do that. As long as you are extending one class, you can implement thousands of interfaces. So I can have extends A, but along with it, I can implement B, implement C, implement D, E, F, whatever, how many number of interfaces you want to implement, you can implement, but you can only extend one class. Okay, so that is another point, because you see the only point is you have to figure out, will I run into multiple bodies of a same signature function? If there is a probability of happening that happening, then that is not allowed. If there is no chance of that happening, then I will allow that. So you don't have to mug up all the rules that one class can be extended, multiple interfaces can be implemented. Don't worry, don't think like that. Just think in terms of the problem. The problem is multiple functions bodies with the same signature. If that cannot happen, then I will allow that situation. Yeah, ask us. Go ahead.
So, sir, if a class is implemented from A, let's call it AA. Then, if I implement again A, is it possible? I mean, to say, if I say class Y extend AA, then A implement A.
Your voice is cutting. I'm not able to hear you properly.
Okay, sir, I'll reconnect.
This sentence I heard properly, but anyways, fine. So this is what we discussed.
Can I have one doubt clarified?
Go ahead.
This is regarding the quiz. One of the question was talking about. Can I read it to you?
Okay.
It says scanner is a method, scan documents is implemented. Printer with the method print document. Copier with the method scan documents and print documents. These are the three abstract types that given. Option is, obviously the scanner is a subtype of printer as well as copier is the subtype of a printer and scanner. The answer given there is scanner and printer both inherit from copier. Somehow, from my knowledge, looks the reverse logic.
So wait. I kind of can you say again? What did you say?
No, the question is consider the following abstract types.
Okay.
Scanner with the method of scan documents.
Okay, just a second. Scanner with the method of scan documents. Okay.
Printer with the method of print documents.
Fine.
Copier with methods scan document and print document.
Okay.
Now, who is inheriting who? That is the question. My answer was copier inherits both scanner and printer.
Yeah, that is fine. No problem.
But the official answer given, and then I think Dipsit or somebody else is arguing, saying that no, scanner and printer is inheriting from copier.
So that's the point. So what is scanner or printer? Are they class or interface or what are they?
That was not been defined in the question. They all say it's abstract types. I mean, once it is abstract, it could be equivalent, as we talked about. It could be abstract. Abstract interface.
No. This is week 3 question.
Yeah, week 3.
Yeah, but see, there they are asking the exact answer is in the slides also. One example is given. You have to think in terms of subtyping and inheritance. Yes, classes.
No, if you
so which is a subtype and which is a inheritance.
We can't keep one leg here, one leg there. Either we take all of them as a class or all of them as a interface.
See, the point is the question.
Week 3 interface is not taught now. So why do we have to worry? Yeah.
So fine. So it is all classes, right? Abstract.
Yeah.
If it is an abstract class, how does the reverse comes into picture? How can I say the scanner is inheriting from?
No, they have not mentioned abstract also. They are just mentioning these are the things available to you. Now, who is the subtype and who is the who you can say as inheritance?
It is in front of me. I just read it. Consider the following abstract types.
Let me hear the question completely. So consider the following abstract types. Scanner is an abstract type. The word uses type, and then we have SD function inside it.
First line is 5 words. Consider the following abstract types. Then there are 3 lines saying scanner with the method scan in document, printer with the method print document, copier with the method scan document and print documents. That's all.
Yeah. Okay. Then after that, what is asked after that?
Identify the current subtype and inheritance relationship between the classes.
Okay. Between the classes.
Yes, obviously it is a class because we are not talking about the interface yet, right? So
Then I
these are
think
abstract types, abstract classes.
then there is
No. See, every class itself. No. Abstract type means it is not a class of abstract type.
Then
Okay, you are.
okay.
See, in OOP, every class is an abstract data type. Okay, so that's what they mean, because every object we create is not a primitive data type. No, they are all abstract
Acha.
data types.
ADT. So there the concept is about ADT, but I think then it should be properly mentioned about abstract data types. Correct. That is also correct.
I'm not quite sure whether you guys are talking what I wanted.
But the point is, even if it is ADT or class or whatever, let us say even if I do not consider that. So if I have,
I marked it to you in the discourse. Maybe you can go through that. There are screenshots and a lot.
yeah. I would do that because I would prefer to see the question statement word by word.
Yeah.
But even if we proceed with that, even if I have a scanner, let's say class, okay, scanner class, SD method, printer class, PD
Sir,
method.
I have pasted in a chat. Sir. So
Yeah, just a second. So copier class with both these methods are there, right?
Yeah.
Now, if I have an inheritance structure, right, then copier class, by the way, so what are the options given to you? Because the options would not make sense if it is otherwise.
Okay, I'll tell you the 4 options. Scanner and
Yeah.
printer are subtypes of the copier, which is wrong.
Because if that is the case,
No.
then,
Yeah, it's. I mean, they also say it is not the choice.
okay, then
Copier is the subtype of scanner and printer.
copier is the subtype of scanner and printer.
Obvious.
Yeah. Okay.
That's accepted answer.
Yeah.
The third option is scanner and printer are both inherit from copier.
Scanner and printer are both inherited from copier. Now the point is, we can have one level in inheritance, 2 level inheritance. So I can have printer.
That is no. My question is, if copier is the subtype of a scanner.
But in either way, just a second. So, but in either way, if I am inheriting from copier, both scanner and printer, then SD and PD would be there inside both of them.
Correct.
Right?
My question is this: if copier is a subtype of a scanner, how can scanner inherit from copier?
Sir, a little bit clarification here. If you see the lectures, no, the subtle difference between subtyping and inheritance is told like this. Subtyping means it extends that particular class as well as has its own functionality also. So copier extends the scan method, SD method, scan document method, as well as it can have its own things, PD, etc. So that is why copier is a subtype of scanner. Subtyping is.
Can I say that subtype is supposed to have something more than?
It may have, it may not have, but generally it will have. Yeah.
It has a right to add more to what it has inherited.
Okay. Just a second. So in this case, if I consider that PD is a property of copier itself, then PD will also be inherited from printer class, and then it is kind of working like an overriding, right? So that's.
Let us not take 3 items. We will consider only scanner and copier. Keep the printer aside. If we get clear about this relation, then we can add another fellow. That's not a problem.
So let me do it like this. I will go through the discourse. Obviously, there is more about this philosophical idea rather than concrete programming idea in this question, right? So I don't want to waste time on that because I have to discuss a lot of things in this session.
Yeah.
In discourse, I will reply, and if there is some ambiguity, we will have to look through it.
Fine.
Okay.
Sir, I'll just take 1 second more. They have just given these 3 things. They have not given a programming statement like copier extends scanner or something like that. They wanted to test us what is subtyping and what is inheritance. That's all. They have not given that scanner extends copier or copier extends scanner and now tell who is who. Okay. They wanted to just know we have understood subtyping or inheritance or not, basically.
Got the point. But still we will go through it and let us see. how
Yes,
it
sir. Yes, sir.
works. Yeah. Fine. So where was I? Let me. Yeah. So. Basically, a particular class can extend one class, but it can implement multiple interfaces. So that is the idea. And why it is allowed to do that? Because interfaces do not have function bodies. That is the whole point. Because if interfaces like normal classes, if it would have had function bodies, then again we would run into that diamond problem, and then or let's say not diamond problem, multiple copy problem, then we will run into problem. I mean, we will run into ambiguity. So because of that, that was not allowed for classes, but for interfaces, since we do not have method bodies, and therefore we can have multiple implementations of interfaces. I can have implements B, implement C as well. Okay. And this is also required. The reason for that is, see, extension of classes means is a relation. But implementation of interface from object-oriented idea, not forget about this programming and syntax error and all of that. From object-oriented idea, extension of classes means you are defining an is a relation. But implementation of interfaces means you are specifying a, let's say, a feature, let's say something facility, some feature that you are defining. Because basically implementing an interface essentially means you are giving the implementation of a specified function in the interface, right? That's what you are doing. So that means what? Like in this example, I told that over here we have this numbers class and comparable interface. So numbers are comparable. So when I'm saying numbers are comparable and overriding the compare method, what I'm doing is I'm adding a feature to number object, which is what? Which is that objects of number type can be compared. So I'm adding this feature of comparability. And therefore, interfaces, basically implementation of interfaces means adding a feature to the object. And that's why I said that these interface names are adjectives, because they define the noun, which is basically the class. So they add a feature to the noun, or in this case, add a feature to the class or the objects. What I mean is add a feature to the objects. So therefore, it might so all happen quite frequently that you might need a feature to be added into an object which is a child of some parent object. This is very, very common, right? Like maybe a boy is the son of obviously his father. So his father class is there and he is a son. So obviously he will inherit from his father class, the boy class. And that boy is, let's say, a very good wrestler. So an interface can be there, which has a method called wrestle, and maybe that boy is implementing that interface and he is overriding that wrestle method. So that is adding a feature to the boy, which is obviously the boy has its own let's say inherited items, which he inherited identities, which he inherits from his father. But again, with that he has an additional feature that he implements. Now, does that feature has anything to do with this inheritance hierarchy with his father or with his with that boy? No. Why? Because wrestling is something which is not related directly to a father-son relationship, right? So it is wrong to implement that wrestling as a class, not implement, to put a class as a wrestling class or wrestling abstract class within that hierarchy. But what I'm trying to do is I'm trying to add a feature into the object. So when you are trying to add a feature, when you are trying to specify a feature, you use interfaces, right? So that is the whole object-oriented philosophy behind it. Okay, so now since we have discussed all these things, now we will come into a new statement, and that statement will kind of contradict with what we have learned till now. And that statement is, after Java 8, so I think it's clear till now that why interfaces are allowed to have multiple implementation. I mean, why a class can implement multiple interfaces. Okay. So one thing I discussed, that a class can implement interface, can extend another class, but there is another thing. Can an interface implement another interface? So interface, let's say A implements this. A has nothing to do with the previous one. Okay, so when I'm just taking random names, so whatever you're seeing on the screen is related with the screen itself. Previously, if A was a class, I don't mean to refer to that. So interface A implements B. Can I do something like this? Can an interface implement another interface? So yeah, this is also allowed. It's correct also. So I am not able to think of something like this as of now, but how should I say, runnable and sprintable. So let's say there are two interface class A, sorry, interface A is runnable. So not A, what I mean is, let's say, sorry. Let's say some, how should I write? Movable, maybe. This should be okay. So this is allowed. Interfaces can, a movable is an interface, by the way. Don't think that extend is there in front of this movable, therefore this is a class. Let me also confirm that, because
An interface can only extend
an interface, correct.
Yes. It cannot implement. Implement always implies method descriptions.
Yeah, that's what I said, right? So oh, right. So I just wanted to tell one thing about it, that always keep this thing in mind, that if you have multiple interfaces, then that is an interface is allowed to have multiple super interfaces within it, but then we will have to write extends. Okay. So interface runnable, extends movable. So you can make sense out of it that running is a basically kind of movement, and movable is a super type of, or super movement of, not super movement, what I mean is it's a type of movement. Running is a type of movement. So therefore the inheritance hierarchy kind of makes sense. So in running is moving. So running is kind of moving. Therefore runnable extends movable is right. But why I wrote movable and not moving or anything? Because movable is also an interface. So assume over here I have another interface movable. And I told you interface names will be adjective. So it will be like this: movable, runnable. So yeah. Okay. So there is some lines of code over here like this. Okay. Again, over here, so this is perfectly fine. Keep this thing in mind. If I am having an interface and it is extending another interface, that is completely fine. But if I have a interface, let's say whatever X, extending a class, then this is not allowed. Obviously, due to common sense, you can apply that. Oh, sorry, both of them looks like X. So basically, extends, let's say not class. What I mean is extend some class. So can be some whatever person. Right? Person is a class. So if this is the situation, then this thing is not allowed. This is wrong. Okay, so interface cannot extend a class, but interface can definitely extend another interface. A class can extend one class at a time, but can implement multiple interface. Okay, so if you are okay with the philosophy of interface and class, you will be able to anyway add a logic behind each of these, let's say, structures. Okay, now coming to the previous discussion, which I was going to start, that till now everything and all this complex structure of interface extending another interface, multiple interfaces being implemented inside one class, right? All of these was allowed because interfaces did not have method body. But now I will tell you one thing, that after Java 8, what happened is, before Java 8, what we learned till now was the way it is, was the way it was. But now what happened after Java 8 is we introduced two new concepts, which are static methods, and the second one is default methods. Static method means, I will come to that. Static methods in interface, because static methods was anyway there inside normal Java in interface. Till now what we have learned, before Java 8, the version was only abstract methods were there inside, right? Abstract methods. On it, right? But after Java 8, what happened is this static methods inside interface and default methods inside interface. Now, what are these two things and why were they added? So first of all, both of these will have to do with the method body being provided. So I can have an interface like this, interface, let's say walkable. And inside this interface, I can have an abstract method, let's say public abstract walk, right? Okay, like this. And then after Java 8, what I allowed was something like public default stroll, another method. Just let's say I took another name, but now I will provide a method body, right? And also public static what should I use? Wait, so I have to use a method name which kind of, let's say, let me give me 1 minute, because thinking the concept to gel up with the idea is very important in this case. So this should be a method which should be very not directly related, or let's say which does not directly conforms to the use of this interface, but this is something which would be required by any object as a utility function. So what I mean is, let's say, as the example I took previously in the previous day session, that let's say you have to do principal component analysis. So maybe you have a function for that, or maybe a class for that. But for that you need to find eigenvectors, right? Now finding eigenvector is not let's say inherently anything to do with the PCA, but rather it's a step or it's a utility that you need to have in order to do the principal component analysis. So finding eigenvector is kind of a utility function. So here you need static methods inside interface, has to mostly relate with the idea of having a helping feature with the main use of the interface. Are you getting what I'm trying to convey?
Can I suggest a name?
Yeah, go ahead.
Get number of legs.
Yeah, fine, great. Or let's say set number of legs is something I would prefer better, because it has something to do with some action. So set number of legs. Thanks. So we have to be very specific while discussing these concepts and these function names, because most places you will see they take a name and they will say the syntactical feature. Okay, so static methods will have body and they will work like static methods. You can call walkable dot set number of legs. All those things are fine. You can read the syntax from anywhere. I mean, you don't have to even attend the lectures or anything, or even the session. But the object-oriented idea is very important, because in most places, if you are really writing code in Java sometimes, and or you are doing software design in any programming language, then the object-oriented ideas are very, very important. And that's what we are trying to discuss in this course, that static methods in these interfaces should be something like utility methods. Okay, so let me just mention this.
Does it mean it will not be implemented in the classes where?
I will come to that part. That is a syntactical part. I will come to it. But let me just set up the motivation over here. Static methods. Static methods of interface. So this is particular to the interface static methods. Okay, interface must be some utility methods. Utility method which performs the task or let's say which not performs, which helps in completing the implementation.
Basically, super functions.
Yeah, implementation of the. I think someone also wants to ask something. Go ahead. Someone else was trying to speak. Is it so? Okay, no. Fine. So which helps in completing the implementation of the specified functions in the class. Specified function in the interface actually, but in the interface implementation of the specified function in the interface. So obviously the implementation will happen in any one class, right? So what I'm trying to say in this case is, let us say the walkable interface is implemented by any class. So maybe camel, right? So camel class is a class and camel implements walkable. So now we will see that the camel has a feature, or camel object has a feature. As we told, that interfaces are basically adding feature. So camel class has a feature, or camel object has a feature of walkable. So a camel object can walk. Now, how will that camel walk? That will depend upon the definition of the walk function. This is the core part of the interface, or core part of the feature, that a camel object is there. It is implementing the walkable interface. Inside the interface, there is a walk method, and camel, how the camel will walk will depend upon the camel, and therefore he is implementing his own version of the walk method, the abstract method. So this is the main core idea, class and interface relation. But now the point is, in order to walk, or in order to implement the let's say walk, how the camel walks, right? In order to implement the walk method inside the camel class, it might need the help of some other things. It might need some, that's what we call utility. That's why I'm using the term utility. What are utility? Utility means it is helping or providing some uses to you. So in order to implement that walk method, camel might need some utility methods or some help. Okay, and that help is something like the set number of legs, because setting number of legs is precursor to how you can walk, right? Unless and until you have a proper set of legs or a proper anatomy of legs or limbs, then you will not be able to walk. So therefore, in order to implement the walk method, the camel object required an external help which has nothing to directly do with the camel, but it would be required in order to implement the walk method. So these kind of methods are called utility methods, which are not very much philosophically related to the camel and walkable relationship, but they are required for providing the implementation, or they are required for helping the camel class or the object to finally write the implementation of the method specified in the interface. So such methods are called utility methods, and we use static for only utility methods. That is the philosophical idea or the object-oriented idea. You cannot have a, I mean, you should not. You can have, because syntax error will not come even if you give any random name or use it for any random purpose. But that is the philosophy behind it. Okay. Now coming to the what do's and don'ts part of both of these two methods. So now if I have a class, as we discussed camel, so let's stick around with that, implements walkable. I'm not writing the whole name. Now in this case, what I have to do, since I have not defined the class as abstract, obviously I have to override the abstract method walk. So that is fine. So let's say I override walk. Okay, and maybe in order to do that, I had to use the set number of legs. So therefore, the set number of legs has some lines of code within it, which is a proper concrete function. Okay, so I utilize the set number of legs function to define the walk method. Okay, okay. Now if that is done, now one more thing. So it's not always that only one walk method will be there and another static method will be there, and that static method will be used to implement the abstract method. It's not. This is just the idea that static methods inside interface are utility methods, but there can be multiple abstract methods. You might need one of the utility method while implementing one of the abstract method. You might not need that. Those are the multiple scenarios can be there. But the static methods, if the definition of a method is provided and if it is kept as static, then it should be done for utility purposes. Okay. So now I override the walk over here inside the camel class. And obviously, in order to override, if I have to call the static set number of legs, I can do that because it is also inherited and the method body is also provided. So this is the reason for providing static methods inside the walkable class. And why we are keeping it static? Why not anything else? Because you see, setting number of legs or having legs to be able to walk is a feature of any walkable entity. It's not something which is particular to let's say, so what I mean is, it's not that dogs would not need legs to walk, but camel would need legs to walk. It's not something which is particular to different objects or particular to different classes which will implement the walkable interface. So it's not like you're getting the point, right? So everyone needs the legs to walk or limbs to walk. So if that is the case, then it should be something which is static. So we would be able to call it using the walkable interface. Or even for the better, let's say for better understanding, let's make it not set. Let's initialize legs. Let's change this to something else. I think that would be better. Because you might think that, okay, number of legs is something which is dependent on animals. So camel will have 4, right? Some other animal might have 2, humans will have 2, so something like that. So let's set it to be initialize legs. So obviously, now it is irrespective of any class bounding or anything, because if you are trying to walk, then obviously the first task you have to do is you have to initialize your legs. I mean, you have to basically warm up or whatever. So basically you have to start, your leg muscles have to start working. So that is the first thing. Now that is very interdependent, that is independent of the class which is implementing that interface. So therefore, since it is not dependent on the objects or dependent on the classes which are implementing walkable, therefore these are static methods. Okay, and therefore I can write over here, override. In order to override walk method, I will use walkable dot initialize leg. Okay, I don't have to declare anything else. Walkable dot initialize leg, because the interface anyway cannot have objects. That's also another point. By the way, I forgot to discuss one very important point while discussing this. just pardon me for that. I would go back to the abstract class concept for 1 second. So abstract classes, we told that abstract classes will have one or more abstract method. And so can I create an object of abstract class? So that is one point. Can someone tell me the answer to that, or what do you think about it?
No, you cannot.
Why?
It's supposed to be non-initializable, non-initiatable, whatever you call that.
Okay, but I mean, what is the
I
philosophy?
can have a class where all the methods are described fully, but still I can, if the moment I define it to be a abstract, I don't want that to be instantiated.
Yeah.
Only subtypes can be initiated. I mean, I don't know, what is it called? Initiate, instantiated.
Instantiate.
Yeah.
Okay, fine. So that's obviously the correct answer, that yeah, you cannot create an object or instance of a abstract class. So what I mean is you cannot call this new thing, new and then class name, right? So you cannot have this for a class name which is an abstract class. So you cannot do this for an abstract class. So that means you cannot instantiate or you cannot create an object of an abstract class. But the reason behind it is because abstract class will have one of the abstract method. That is correct. But the philosophy behind it is that if I have a behavior which is not mentioned or properly implemented, then I am telling you that, okay, I have a behavior of an object or of a living entity or whatever, some data entity that is supposed to behave, but I don't know how it shall behave. So that's what it means to have an abstract method in a class. And basically that's what it means to have an abstract class. That there is something which is a real world entity, and I am also telling you that that entity must behave in a specific manner, but I don't know how that behavior will happen. So it's like I'm telling you a human should be able to talk. I'm telling you that he should be able to talk because human abstract class, let's say human class is there, and inside human class there is a method called talk. Now I make that method abstract, and I also say that the human class is therefore also abstract. Why? And therefore I will not allow objects to be created. That is, I will not allow humans to exist in real world. Why? Because if I'm saying that humans are supposed to talk, but I'm not telling you how humans are supposed to talk, because how part is the body part, function body part. So then that kind of item should not exist, because I'm telling you that this should happen, but I don't know how this should happen. So this is something ambiguous. So this is the reason philosophically that abstract classes are not allowed to be instantiated. And syntactically speaking, yeah, you cannot call the new method, new keyword and create objects of abstract class. Now, if that is so, then the other question is, do abstract classes has constructors? This is again a very common question. So yeah, I will answer that without much asking, because it's not a lot of to think that abstract classes obviously would have constructors. That is, although I cannot call this new class name over here, but there would be a constructor inside the class of abstract class. And the reason for that is because abstract classes are basically used for, or can be used for inheritance, right? It can be there inside the inheritance hierarchy. So if it is there inside an inheritance hierarchy, we know the constructor call sequence in case of an inheritance, right? So when you have a parent class and a subclass and you create an object of the subclass, right? So when I write something like this, that parent reference 1 equal to new child class constructor. If I write a line like this, so this means I'm only calling the child class constructor. But when you are calling the child class constructor, inside the body of the child constructor, there is a no argument super call. I think that has been discussed in the constructors discussion. So no argument super call. So what I mean is, inside the child classes constructor, before allocating any feature corresponding to the child objects part, the constructor of parent class will be called. So therefore, in case of constructor chaining, if an abstract class is there in the inheritance hierarchy, and if that class does not provide a constructor, then there will be a break in constructor chaining in the inheritance tree. And because of that, obviously abstract classes also have constructor, but although they have a constructor, we cannot create objects by using that constructor. So you cannot call the constructor, but there are these constructors of abstract class.
Are we saying that we have to define?
No, I'm not saying we have to define. I'm saying it is there.
Yeah, it's invisible.
Yeah. Even if you want to define it, you can define it, but it's not like normal. No different than the normal class. It's there, but you want, you can do it. You don't want, you don't have to. Okay, so now the main thing is, since objects are created by calling constructor and abstract classes do not have objects, many of us initially have this idea that we cannot create. You cannot create objects of abstract class, therefore abstract class does not have constructor. But that's not the point. So if someone has that doubt, that's what I wanted to say. Chalo. Next thing is, what I was telling is this class camel implements this walkable now. Now I override this walk method also. But the thing now is I have this static initialize legs inside this class. So let's say I have this initialize legs over here. Just the image, like consider this is present inside the camel class, right? Now the thing is, let's say I am also implementing another interface, and let's say that interface also have a method called initialize legs. Okay, and let's say a static method. Or let's say I am extending another class, because camel class has implemented only one interface. So I can extend another class, right? That is not a problem. So I can extend one class, and let's say in that class again, I have another method, initialize legs. And that method obviously would have a definition along with it, and therefore I will again have multiple copies inside the camel class. Getting the point? So initially, the reason why we allowed interfaces to be implemented multiple times, or what I mean is not multiple times, what I mean is we allowed multiple interfaces to be implemented within a same class. And we did not allow multiple classes to be extended within a same class. The reason for that is because we did not have the method body, which would create confusion in case of interface. But now, since we added these two kinds of method, which has method body after Java 8, inside interfaces, the first is static method, another is default method. Now we have this trouble of again going back to the same diamond problem, that basically you will have this ambiguity about calling which version. If you have two separate sources of the same method name, and you can have that same separate sources, because according to Java rule, you can implement multiple interfaces. So let's say two of the interfaces have same named method. Same named static method or same named default method. So obviously they will have their bodies, respective bodies in their parent interfaces. And when you inherit or when you implement them, then basically both the bodies will be there, and you will run into confusion. Also, if you basically do it with a class and in the interface, then also there is a confusion. But here is a difference. So there are two cases. Okay. First is a class A extends, let's say B, and implements C. So obviously B is a class and C is an interface. C is interface. Now in such a situation, suppose both B and C have a method 1, and which has a body, concrete method. Okay. Now the thing is, in this situation, although there would be two bodies of one method inside A, right? One from B, another from C, but there will be no confusion. And when I said confusion, what do I mean? While, let's say, while doing this, okay, there will be no confusion while doing this. Why? Because the priority of class is more. So whenever I have multiple copies of concrete method from multiple sources, that can be a class, sorry, not that can, that E, and if those two sources are class and interface. One of them is class and the other one is from an interface. So in such a situation, the classes version will prevail. So in this situation, D's version of fun will be called. Okay, but in the second case, if I have this same class A, but it implements two interfaces. So let's say implements C and implements D. Let's say D is another interface, and same thing also happens for D. So in this situation, when you have two interfaces, then you will run into confusion, or let's say error, whatever. Okay, so while doing this new call, right? So how to deal with this? So the solution is simple, that you have to override. Overriding fun. Inside A. So inside the class, if you override the fun method, then it's okay. Then it is allowed. Then you don't have any problem anymore. It is allowed. You can have this both C and D, and you override the method fun, and then there would be no trouble, because that overridden version will be called when you execute this line. Okay, but if you do not override, then there will be error. Okay, so basically not overriding will lead to error. Okay, so this is also discussed. Now, so the multiple copy problem, we kind of worked out how to deal with it. But I did not discuss one point, which is static method. We kind of discussed the motivation of why static method. So if we are, the main idea was to avoid the multiple copy problem or diamond problem somehow, and therefore we did not allow multiple class inheritance and allowed for interfaces. But later we introduced these two kinds of method, and because of that we again ran into problem of multiple copies. And then we saw, if I have a class and an interface, so then I am taking the classes version, even though I have multiple copies with body part of the method, right? But if I have if I have two or more interfaces having default or static methods of the same signature, then there is a trouble, and then we have to override compulsorily inside the class which is implementing both those interfaces, and then it is okay. But if I do not override, then it will give me error. It will give me compilation error, right? But the point is, even though we kind of solved this trouble, but why did we introduce these two kind of method in the interfaces after Java 8? So the first is static method is introduced. The reason for that is, what happened is, after Java, since as the programming language was developing, after Java 8, I mean, when we came to Java 8 version, some additional features were added, and those features were completely, let's say, fundamentally different features. Okay, very new kind of things, and we will learn that thing in, I think, week 10. No, not week 10. Week is 8 or 9. We will learn about that feature that was added, and some other than that also. One of them we will learn, and some new features were added inside Java. So because of the addition of those features, we have to also change the libraries which were existing earlier. I mean, which were basically, in order to add the features means what? We have to add some things in Java 7 code base, right? Now, let us say you have an interface in Java 7 code base. Now, all the people in the world who are programmers, they are writing using Java code, a Java language, and let's say they have written code for their own companies, and they have used a particular interface which is there inside Java. Okay, so one more thing, it's not that there are only interfaces which you are defining. So like you can define a class in Java, but Java also has some predefined classes like object class, like there are multiple classes, scanner class, right, which are the library functions, and not functions, basically the structures which are already defined, which basically makes the code base of Java. So these classes and functions and interfaces, there are multiple things, multiple interfaces which are already predefined, which makes the code base of Java, right? Now, if you are using, we will learn about such interfaces in the later part of the course. So when you are using such an, let's say in Java 7, there is such an interface which has some specification abstract methods. In Java 7, there was no default or static method, right? So only abstract methods were there. Now, the people in the world, the programmers in the world, they have used that interface to implement and write a particular class. Different people in their own industries have written their versions of their class implementing that interface. Now, what happens is later on in Java 8, the Java developers came and said that, okay, I want to add a new feature, and in order to do that, I need to add a new function definition, function declaration in that interface, which interface was used by multiple people in order to implement their classes. Now, inside that old interface, that library interface, which was predefined inside Java, to introduce a new feature in Java 8, the Java code developers, they came and they added a new method declaration inside the interface, that interface. Now you tell me what will happen to the code base of all the people who have written code using the that particular interface. I told you that every class which is implementing a particular interface must compulsorily override all the method and provide the method body. Overriding means that, right? Providing the method body of all the abstract methods. You should not keep even one abstract methods unimplemented. Because if you do not implement even one abstract method, so then you have to declare your class as abstract. So this is the reason you have to implement all the methods. Now, if I add one method inside Java 8 interface, which was previously used by the programmers around the world to implement multiple classes, then they are not aware of this, right? And you have added a method inside that interface, and that interface is being implemented by different people around the world previously in their code base. So all their code base will break, because when they compile using the new Java compiler, it will say that that your class should be abstract, because one of the method is now added inside the interface and you are using that interface, and because of that you have to also implement the definition of that method which I have added. But they might not need that, right? That is something which the Java developers have provided to add an additional feature. But maybe one person in New Zealand, he has already written a code and he is happy with his code and it is working fine. He does not have to worry about all of that, right? But he has to compulsorily again override that method which the Java people has introduced in the interface as an abstract method, in order for his code base to work properly when he is installing the new compiler and running his code and compiling on that. So that is the reason your code bases around the world will start breaking. So this is what started happening when they added these few features, new features in Java 8. If they just add, in order to add those features, if they just added a new abstract method in the interfaces which are predefined inside the Java language, then those people who have already written code using those predefined interfaces, their code will break, because the classes will have to be made abstract, because the new methods are not implemented inside the previous code bases. Okay, so this is the reason the Java developers told that, okay, so let's do it this way. We will introduce these default methods. So whatever new methods we are introducing, let's introduce them as default method, and we will provide a default implementation of them. If someone wants to use these new features, he will override the default method and his version will work. If someone who does not want to work with this new feature and is happy with his previous code base, then he does not have to do anything and his code will also not break, because any class implementing the walkable interface will not say anything about abstract, because this has already a definition as long as it is a default method. As long as, so that's why we call the term default, that it is a default implementation given for a feature. If you want it, you can override it and use it accordingly. If you do not want it, you don't have to worry about your code base breaking. So therefore, default methods were introduced in order to, let's say, allow adding new features into the Java language while keeping a back compatibility option for the previous code bases. Okay, so that was the reason for default methods. And static methods I already discussed. These are for utility behaviors. So as I said, that once new and more complicated features were added, you see that you would need, in order to implement the main method of the interface, you would need some facility or you would need some help, which is not directly related with the class interface relation, but it is helpful for you if you have some extra utility methods. So in order to cater to those needs, static methods were added. Okay, and why static methods were added with definition? Because if you do not have a definition, then again you have to have another class that has to implement that other class. I mean, not the camel class or not the class which is required to implement the walkable, just a utility class in order to have the definition of that static method. Right, so that is something meaningless. So therefore, we added the static method with definition. So this is also a very important concept, and it is not discussed in this detail in a lot of places, but it is important and understand this properly. Okay, fine. So, yeah, so we have discussed all the topics of interfaces, abstract classes, and how interface should work. Obviously, interfaces can serve as references. As we have already discussed, abstract classes were not allowed to instantiate interfaces. Obviously, therefore, they are much worse than abstract classes in that respect, at least, and therefore, obviously, interfaces also cannot have objects. So you can only define reference variable of interface. Coming back to the main motivation of our interface and abstract class, that is what you required, right? You had this ML type, and once you have this ML type, as long as it is able to store objects of all its subtype, you were able to have the dynamic dispatch with you. So that was the main reason. So you need a reference which is super type of all of these. That was the main idea. So therefore, interfaces can work as reference variable only, and you cannot instantiate interfaces. One more thing, interface does not have constructor. Like classes, abstract classes have constructor, but you cannot instantiate abstract classes. Interfaces cannot be instantiated, and it also does not have any constructor. Yeah, so the basic things of interface and all the abstract classes are done. Let me just see the slides once to have a reference of where we are standing. Generic function, right? So this kind of this display function which we had, I will come to this description. This comparable over here. Okay, I will show this with a code. Maybe that would be easier. I will show it with a code now. Generic function. Okay, so how we can have a generic function? Generic function means what? Suppose I want to do a particular task. Maybe I want to, in this example in the slides, we are sorting. So I want to sort a what? So that's the point. I want to sort any type of item. So if you want to sort, let's say, numbers, then you have to write a specific code with respect to the logic for sorting number. If you want to sort, let's say, strings, then you have to do it accordingly with the lexicographic logic, right? Syntactical logic. So basically what I mean is, in order to sort multiple different items, you have to follow different strategy or different rules. So how can I have the a generic kind of function which would be able to sort all kind of stuff, right? So that's what we are trying to target, and interface will help us in doing that, right? So you might have used in Python, you write sort function, right? Inside sort, you give a list, it will sort. You give a list of, you give a string, it will sort. You give a list of something, that it will sort. Whatever you give, it is sorting. The same method. How is it doing that? So that's what we are trying to achieve over here. That I would try to make a method which would be able to sort different data types of item. Okay, and yeah, so that's what we are trying to aim, and interface will help us in doing that. We will see that in code just after this. Let me see what else is there. Multiple inheritance we have discussed. Okay, interfaces. Conflict between static, default, all these things are done. Okay, Okay, so this is something else. So fine. Before this, we will go to that code, as I said, how to make a generic behavior comparison. So I hope my screen is visible. As you can see here, that explanation of why we need interface and how this code is there in the code walkthrough session. I'm just using that. In the code walkthrough session, you can see I have explained it over there in detail why we are doing what we are doing over here. So what we are doing is explaining why we need interface and how interface provide polymorphism along with customizable utility. So what do we mean by each of these terms? So polymorphism, how it is providing polymorphism, that is, I think, a little bit okay with you guys, because as you saw that by using the interface or primary motivation function, the ML function, right? So basically in this code, what I could have done is, instead of having this empty kind of structure, what I could have done is right. So interface ML, public void display, and all I have to do over here is implements. And right, that's it. So this is a much more, let's say, more structured or more elegant way of writing the same code. Instead of having that empty function or stuff like that, we have this interface. Okay, so everything works, as you can see, everything, there is no error in this code. So the primary motivation, that's why I gave this example, that we are trying to have the motivation for the existence or the origin of interfaces. Okay, now, so polymorphism is okay, because you saw that by having that interface machine learning, we were able to exploit the dynamic dispatch, and we were able to call the display method for different subclass versions. So that was your dynamic polymorphism part. Now, why is this customizable utility? So the reason for this customizable word over here is that, as you can see, if I would have used object class directly, suppose somehow, even if I do the typecasting, one of the problems with typecasting is that, I mean, you have to check the instance of multiple times. And if the inheritance tree is very big, then you have to check instance of a lot of times. I discussed that in the initial part of the session. Just have a look through it once again. So that was one disadvantage. But there is another bigger problem over here, and that is object class is the superclass of any class in Java. And because of that, you would not be able to differentiate between the functions. So let's say let's say there are two inheritance structures, right? Let's say inheritance structure means parent class 1 and child class 1. And parent class 2, another completely different inheritance tree. Parent class 2, child class 2. Parent class 3, child class 3. 3 different inheritance tree. And let's say 4 different inheritance tree. Parent 4, child 4. Now I want my parent 1, child 1, and parent 2, child 2 to be related, and parent 3, child 3, parent 4, child 4 to be related. So inheritance structure number 1 and 2 can be related by any common feature, and 3 and 4 can be related by any common feature. So let's say 3 and 4 are I don't know, maybe animals or living beings, and 1 and 2 are, let's say, machineries, something like that. You can think of any situation. What I mean is, there are 4 independent inheritance structures, and 1 and 2 has a common feature between them, which can be related by is a relation, just like we related unsupervised learning and supervised learning. They were independent structure, and we related them by using ML, right? So 1 and 2 is like that, and 3 and 4 is like that. But if you want to do this pairing, do this customization, that 1 should not be mixed with 3 and 2 should not be mixed with 4. If you want to do this thing in a situation where you have objects of all these 4 independent inheritance structures present inside the same array, object array, then you cannot have this. So if you have an object array in which you have objects of parent 1, child 1, parent 2, child 2, parent 3, child 3, parent 4, child 4. All these types of objects are there. Then you cannot specify this customizable relation that 1 and 2 structure should be related. That is parent 1, child 1, parent 2, child 2 can be having a common function, and parent 2, parent 3, child 3, parent 4, child 4 are having common behavior. You cannot have this because everything is stored there inside the object class reference, right? So if I want to have these kind of groups within inheritance hierarchies, grouping within inheritance hierarchies, so in such a situation, I must have interfaces, okay, which will do that grouping. So I can have an interface tying up 1 and 2 structured together, another interface tying up 3 and 4 structured together. So that would always, now once I have that, and now if I store all the things together in one location, then I will use the reference variable accordingly so as to refer to that particular object type. These things will be clear when you see the code. I just kind of wanted to give an overview why customization is how customization is ensured by interfaces, which is not possible for object classes. Okay, so that's why I said that you guys have to think a little bit, go through the codes, try to think what is happening, because then you will understand all of these things that I'm saying. Otherwise, you will not understand. Until you code it, you will not understand what I'm trying to convey. But okay, so let us take this example. So it is in correspondence to the slide comparison and sorting example, like generic function, which Sir told, right? The generic behavior of functions. So how to use interface to make generic function. So here we are declaring a comparable interface, okay? And we have a CMP function, which is basically comparison function. So basically any class who implements this comparable interface has to implement the comparable CMP function according to its own logic. So whatever class, different classes or different types will have different logic to do comparison. So accordingly, they will implement the CMP function. So by the way, why again I have a comparable S parameter over here? The reason for that is since you are comparing something, obviously we'll compare things of similar types, right? So therefore, if CMP is inherited and overridden inside any class which is implementing comparable interface, so obviously it is a member function of that class. CMP will become the member function of that class. So I will call object 1. I will declare, let's say, 2 objects of that class, obj1 and obj2, and that class obj1.cmp, inside bracket I will pass obj2 to do the comparison between obj1 and obj2. Both of them are comparable. I mean, both of them belong to the same class, and I would be able to compare them. So this comparable is basically taking the second element of the same class, which is implementing the comparable interface. Okay, fine. So now here I have 2 classes, student class and employee class. Okay, these 2 classes are there, student and employee. Both of them are 2 different types, student type and employee type. Obviously, student has, let's say, student name. Your employee has employee name, years of work and salary, and student has marks and name. Okay, now get details is a getter function, and the main part is this, because I'm implementing the comparable interface for student, as you can see over here. So therefore, we have to define this method, and we are defining this method according to the logic of a student. CMP function, why it is returning 1, -1 and 0, Sir has explained in the slide. Just go through that. I'm not explaining it. So basically, we are making a greater than, less than check and returning accordingly. This is the convention used for less than. If it is less than, then you use -1. If it is greater than, you return 1. So that's the convention. If it is equal, return 0. So on the basis of marks, I'm comparing students. One important point is, before writing the code for student, since I have to basically access the marks variable or the properties of the student class, therefore I have to make the reference which I got over here, S, right, comparable S, to student type. So therefore this is the first line, and this is very important. Keep in mind, you cannot change the CMP function's signature. So in the interface, if it is declared as comparable type as the parameter, then you have to have it comparable. And why we declared comparable? Because any class who is basically implementing that should be able to run the comparable CMP function, and therefore we will write comparable over here, not student, not employee, not any other type. But when we are defining the method inside that particular class for the CMP method, so now here it is for student class CMP method, here it is for employee class CMP method. So then we will do the typecasting before starting the work of comparison pertinent to that particular class. So therefore we are doing here student S, because why? Because if I write S before doing the typecasting, then it will not be able to refer to marks, because S is a comparable type and comparable does not have any field called marks. So we are doing the typecasting, and why this typecasting is okay? Because student is a subtype of comparable, right? So therefore it is okay. And then we are writing a logic, so that's not important. Similarly, for employee, we have a separate logic. Just like that, we are typecasting the employee and then writing a separate logic. Likewise, if I have, let's say, another another class called numbers, so I can write class numbers implements comparable and declare and define a CMP method in a specific manner. Suppose I have another class called fractions. I can again have the CMP method. I can implement the comparable interface and override the CMP method to compare between fractions. So what I mean is there are different types: employee, student, fractions, number, dinosaurs, whatever. So all of these things, all of these classes, they are able to override this method according to their own need. But still you might not be seeing the magic behind this, because this is quite I mean, how should I say, quite shallow. That okay, you have an interface, you have a specification, multiple classes are implementing that interface, and then they are providing their own specification. But where the actual power of this thing lies is, I would come to this main method now. Okay, so before that, just one more thing. So till now we have this student class and employee class that we have defined, and inside each of these class we have these two methods. We have the implementation of CMP method. Now, in order to sort, I mean, we are doing a quick sorting. The slide sir has given an example of sorting, a generic sort function. So in order to implement that, we have to write a sorting code, right? So that is just comparison. Comparison always happens between two items. So just first number, second number, first student, second student, first employee, second employee. So basically I'm comparing between two items, and that's why the CMP method had one comparable as parameter, right? So, but sorting requires a much more task than much more to do with that, right? So we have to do multiple comparison between all multiple pairs of numbers and then complete the sorting process. So in order to do that, we have defined a class over here. So these kind of classes are called utility classes. So these are providing the utility of sorting something. Okay, so I'm writing. I have written. This is basically a quick short code. So those of you who have done PDSA, they are quite familiar with this code. Those of you who have not, don't worry. You don't have to understand this code in order to understand the Java or object-oriented programming part. This is just a normal quick short code. This is an algorithm of sorting. Okay. But the important part for you guys to observe over here is, see, when I'm writing the sort function, I don't know which type will use this function, right? As I told you in the first session or in the second session, please have this idea while coding in Java that while you are working in a real world example, there would be multiple people working at different levels. And all these different people might not know all the parts of the code or the whole part of the code. They might work in their module, and you should write your module in such a way so that if someone else is calling a particular method from your module, it should not be very much hectic for him to understand what that code is doing, right? So there is a level of abstraction between different people working at different levels, and every one of them will not know the whole code. So while, let us say in this situation, when you are writing the sort, let's say you are the writer, basically you have sat down to write a generic function for sorting. That's your idea. And you want to make a .java file in which there would be a function, and whenever someone else is going to write a new code, let's say some new .java file, in that new .java file, this new person can basically call your method of generic sorting, and he can sort his class type. He can define any class that he wants. and he can define multiple objects of his class. And then only thing he did is he is providing the CMP method definition, that this is the logic that I want my class to be compared with, my class objects to be compared by this logic. So only the CMP method definition he gave, and he defined his own type. Right now, you don't know in the past that who will define what type. Because of that, you have to use something which would be able to take object of any type variable that in future might be used, right? So in order to have this feature, we need a container which would be able to hold any object or any type which future programmers or some other programmer would be defining, and he would be trying to do sorting on that type, on that data type. So in order to have this feature, we have the comparable interface. So now I will define my sort function as a programmer of generic function. I am defining my whole sort function code inside this class sort functions by using comparable. See over here, I have nowhere mentioned student or employee. There is no mention of, so here the class ends. There is no mention of student or employee. So basically, if later on also I create another new type, let's say dinosaur, then also I can call this quickshot method and pass the dinosaur objects which I created to do the comparison. Only thing that I have to take care of is that the dinosaur class must implement the comparable interface, and that is the let's say leverage that I'm using over here, that I have written the whole sort function on the basis of this comparable reference variable, because I know that anyone who is trying to use my sort function will have to provide the logic of comparison between two objects. He does not have to provide the sorting code that I'm writing, but he has to at least tell me that what is the basis of comparison between the types of his class, or between the items of his class type, right? Because that would be different in different types. So that I am not supposed to know. So that he will tell, and the sorting I will do on the basis of that comparison logic. But in order to provide that comparison logic, he has to implement the comparable interface. That is the contract that he has to follow. And if he implements the comparable interface and defines the CMP method in order to provide the comparison logic, then I can write my sorting code with this comparable reference variable. That would guarantee me that any class which is any type which is defined by any programmer in the future, his data type or his objects would be able to be, I would be able to accept inside the partition method or inside the quickshot method, because they would be some subtype of comparable, because they are implementing the comparable interface and they are defining the CMP type. So basically that class object can obviously be stored inside the comparable reference variable. So this is the idea. I kind of said this multiple times, because this is how the comparable interface is helping you to, in order to, by working as a super type reference variable, and you are making a contract with anyone who is using your generic function in order to sort his items. The contract is that you have to implement the comparable interface, and that would help me internally to accept his objects inside this comparable type array, right? As this is a reference of super type, and as it will become a reference of super type. And another thing is he would have to define the CMP method, because that is something which is let's say particular to the data type that he's creating or the object type that he's creating. I don't know that what object type someone will create and what should be the comparison logic between the items of his type. So that he has to provide, right? So this is basically a generic sort function. This whole thing till the end is a generic sort function. And the most important, you don't have to understand the logic over here. The only thing that you need to understand is why I have written comparable and not student and employee. Okay, so that's the point. Everywhere I'm writing comparable inside this. This is the only observation. Now, in the main method, we are not doing anything. We are basically having two arrays of objects, students and employees. And then you see this is the beautiful line of which proves the generic behavior, that I'm writing sort functions dot quick sort, calling this quick sort method, and inside this I'm passing a student array, then I'm passing an employee array. So any array I pass, as long as it is an implementation of, as long as the class implements comparable, I would be able to use it in a generic kind of fashion, right? Fine. So that was the whole idea of generic function. You can go through this code in the code walkthrough. I have discussed these things. Anyone has doubt or anything to ask in this part? Okay, fine. So this is done. The next part we will cover in the next session, which is iterators and nested classes. Just one thing I would briefly mention, because most probably that would not be discussed in the next session or in any session, because that's not there in the lectures. So I would mention this briefly. We will see in this code that iterators and callbacks, and basically the topics that will come just after this, they will deal with something called nested classes or inner classes. I will not go into the discussion of inner classes. It will be done in the next session. But I would just mention one thing, that inner classes means what? By the sound of it, it looks like that we are packing a class inside another class, something like that. So, but if I tell you that we have done something similar to this previously, so if I have this class, right, class, let's say outer class, the name is outer, suppose, and then let's say over here I have another class, let's say inner class, and I told you that we can have an object of a class inside another class as a data member. Right? We have seen this thing. So this was what has a relation. I told you this example in the previous Saturday session. So this is nothing but your has a relation. So this is one way. Another way can be class outer and now instead of having an object of the class, what I do over here is okay, so we have now the complete inner class being placed inside the outer class. And then maybe here you can define object inside the methods of the outer class. You can work with the inner class object, whatever you want to do. But the primary difference is that here we are placing the inner class inside the outer class. And there is another very, very important point, and that is your this private, sorry, right? This private thing. Okay. So why are we making it private? So those things will be answered in the next session, but here we are primary difference between these two is we are keeping this whole thing inside, and here we are making an object of it. So both of these relations are basically has a relation. So this is just for your knowledge purpose I'm telling. This is not directly there in the slides, but this is very important in terms of software design. This is also a has a relation. But because here also the outer class has an inner class, right? So if we want to write something like this, that I can have a body, let's say class, or let's say, let me just make a modification over here. Let's say I call it class body. And let's say I make a modification over here, hands. So class body, inside it I have a private class hand. So body has a hand or has hand. So basically, yeah, so that's the point. So let's remove this and write hand only. So body has a hand. So it makes sense, right? So therefore this is completely fine. So body is having an inner class and that is hand. So that means body has a hand. So it's fine. And over here as well, we had this outer class and inner class as an object inside it. That also was a has a relation. The outer has a inner. So same thing here also, you can take a body and hand relation, hand ID or anything else. But obviously from the structure, it looks quite a lot different. It's just an object inside in the first case, and in the second case, the whole class is inside. So the main discussion that I wanted to do is not the conceptual parts behind each of these things, that will be done in the next session, but the programming design part behind each of these things. You are allowed to, not allowed, you are motivated to do, or you should do the first option. You should make your code in the first way when there is when the inner class, this class named inner, that can exist. What I'm saying is that can exist without the outer class as well. So it is not that the inner class can never exist without the existence of the outer class. Okay. So for example, let us, I think in the previous case I took, let's change this to outer class name to, let's say, aeroplane. Okay. And let's say the inner class name, I change it to what should I write? Let's say bad. I'm not able to think of anything. Let us say something which is not very, let's say jet engine, or hypersonic engine. Okay, so let us say the hypersonic engine is there, and here I say, it's kind of very poor example, but let us still stick with it. So we have a aeroplane class, and then we have a hypersonic engine class. So now hypersonic engine can be used in multiple cases. It can be used in a, or let's say this is, in a fighter plane, it can be used. Sometimes it can be used in combat helicopters as well, right? And so hypersonic engines can exist on their own. They cannot, there is no compulsion that an engine must, hypersonic engine must exist compulsorily within an aeroplane, right? It can exist on their own also, but aeroplane might sometimes also have hypersonic engine inside them. So aeroplane has a hypersonic engine, therefore the aeroplane has this object. So the has a relation holds, okay? And but hypersonic engines can exist on their own as well, in their own accord, because they might be used in some other classes, or basically in other vehicles, maybe fighter planes, maybe some combat helicopters, maybe whatever, some different fast ships or something, right? Not ships, don't know ships. So basically, yeah. So stuff maybe is missiles, right? In missiles, in cruise missiles, multiple scenarios. In those things, hypersonic engines can exist as well. It's not that the hypersonic engine is compulsorily, or it is forced, or not forced, it is compulsorily, it should be present inside the aeroplane body, and outside the aeroplane body it has no existence. It's not like that, right? So therefore that kind of situation, real world situation, you can program using, or you can represent in programming by this manner. Why? Because you can understand over here that any other class can also have an object of the hypersonic engine class. I can have a cruise missile class over here. I can define a class, let's say cruise missile, and I can have another hypersonic engine OBJ. Let's, for the sake of clarity, name it OBJ2. So this is a perfectly fine syntactical, let's say, code, right? No problem with it. So you can have multiple engines in different vehicles, but not vehicles, different entities. So therefore, this kind of relation is a hazard relation, and it is called aggregation. right? Where there is no compulsion of the existence of a particular inner class inside one particular outer class. I have an independent class and that feature is being used by different classes, right? So the item has its own unique existence. But in this case, if you see, let's say, make it from hand, let us make it a little bit more, let's say it heart, right? So now heart, any animal, a heart cannot exist outside the body, right? If you keep it outside the body, then it will not, I mean, body means I have written body, so it has nothing to do with human body. What I mean is body, animal body, human body, anything. So as long as it is body, that's why I named the class body. Heart cannot exist outside the body, right? It has to present inside the body. No one else, no other class can go and ask that I want the heart object, right? So it is not supposed to do that. So in such a situation, real world situation, where the existence of a class must compulsorily be present only inside another class, or the existence of one particular item is only making sense when it is present with respect to another item, right? And that is the only one-to-one correspondence. It cannot exist outside of it. And that means no other separate class can have an object of this class other than the body class. In this kind of situation, you have to, let's say, represent in programming, then you use this method. Now this is also has a relation, right? Body has a heart. Obviously there also it is same, but here you cannot have another class over here, class some XYZ, that can create, let's say, heart obj. This is in syntactical, it will not allowed, because XYZ will not see the heart itself. It will not see that there is any class named heart. This heart class is private to the body class, and only body class is able to use this particular heart class. It can only outside the body class, there is no existence of the heart class. So over here inside main method or inside some other class, no one would be able to create an object of the heart class, and no one would be able to access the heart class. Only body class can access the heart class. So such a type of hazard relation is called composition. Okay, where it is compulsory to be present inside one particular. So I have not discussed in detail about these inner classes. That will be done in the next session, and sir's lecture has also described that. I just wanted to mention this thing in real world scenario. When you do object oriented design, when you see a situation like this and you have to create a software schema, let's say you are basically writing a module from real world to software. If you are representing it in the form of a code, then please keep this thing in mind, where you have to use what. Okay, fine. So I think in the next session we will continue with nested classes and inner classes, and then we will see iterator. These are the two concepts that are left that we will do in the next session. So thank you all for joining.
Sir, one question. Hello. Sir, what would be a practical example or a use case for the inner class?
I told na.
Composition
example only we will see. Composition example is iterator. And in the lectures also, since I have discussed this now, if you see the lectures, you will see that sir has described composition improperly. See, the idea is in the lectures and as well as in the syllabus, the nested classes, inner classes, having an object as a data member, all these things are there. So you don't have to worry about that. But only this idea is not mentioned, that this is composition, and the main idea is when you want something to exist only inside, and it should not be able to be, it's about its existence, no one should know outside the class. Such a situation, real world situation, if happens, you have to represent it in this manner. These ideas might not be that much highlighted. So I just mentioned that. Now if you go through the lectures, you will see that the whole week, I mean the 4th, 5th and 6th lecture are regarding this idea only. So you will see iterators, callbacks, these two. See, you asked real world concept. So real world concept is real world in terms of programming real world. Okay, so so what I mean to say is, as you can see from this session, live session, we have started answering questions, or let's say started discussing concepts like generic function, how to write generic function. So in Python, you guys, as I told, in Python, you guys did use generic function, that you have sort function that was able to sort all types of data. You have never worried about what is happening internally. How can I put strings, numbers, whatever I'm putting inside that sort function, it is magically sorting. Obviously, the logic of sorting is different. But then how is it possible for one function to understand all types of sorting logic? So, but now we saw one such example, that how to take care of that, how it can be taken care of in a beautiful fashion using interfaces and polymorphism. So my point is, from this, from this week 4, our main motivation for this course would be to learn these programming constructs, how these programming constructs are written, not anything else, but really how, when you're using a particular programming language, which you have already used, Python or some other languages, right? How these things internally work. What is the software design idea behind these things? How using simple elements you can make a generic behavior, or how you can make this, private classes and nested classes can be used to implement different concepts. So we will, as you said, real life example. What I want to stress is real life example in terms of programming tools, right? So one of the tools is generic function. So you can write generic function using interfaces, by using interfaces. So that is a real world example of how to write a Python sort function internally, how the Python sort function works. Another real life example for this composition is your iterators, right? So as you will see in the lecture 6 of this week, the iterators concept is based upon this composition idea. Now, what are iterators? I think in Python also you have seen that when you have a, let's say, particular data structure, a dictionary or anything else. So how did you traverse a dictionary? You wrote a for loop, and then inside that for loop, you can have a variable, and with that variable, you can travel through the key value pairs one by one, right? So how is that variable being able to travel through that complex data structure? It's not an array, so that you do 1 + 1, it will travel. No, right? It will travel. It has internally, there are multiple things going on. So how those things are taken care of? So that is an iterator. Iterator means any variable or which would be used for iterating through a data structure. Now the point is that data structure can be of any object type. I am not providing you the object type. Even I am not providing you whether that data structure is an array or a linked list. I will not tell that. But you should be able to have a specification or a system such that you would be able to generalize the behavior of iterating through a data structure. So how to write an iterator? So that is the real life coding example of composition. We use composition to make iterators. Okay, which is there in your lecture. There are other thousands of examples. That is one of them.
Okay, sir. Thank you.
Yeah. Fine. And obviously, it makes sense now that an iterator cannot exist unless and until you have a data structure, right? When you have the data structure, the iterator corresponding to that data structure only makes sense. I will have a different iterator traversing logic for another different data structure. I cannot have one logic for traversing logic for all the data structures, right? That would be meaningless. Different data structure would have different traversing logic. So therefore, it does not make sense for iterator to be universal. Iterators are very particular to that particular data structure, because that particular data structure will have a specific traversal algorithm. So therefore, that means what? I must put iterators in the scene in such a manner so that outside the existence of that data structure, the iterator should not exist, because it is meaningless. That logic of the iterator will not hold for other data structure or other items. So therefore, as long as the data structure is not there, iterator will also not be there. So this is the reason we use the composition as a relation for iterators by making it as a private nested class. And once we discuss the iterators, these things will be much more clear. Okay.
So you mean to say that for a particular data structure, we would be having one iterator, and that would be an example of a composition. It cannot
exactly
otherwise.
Exactly. And that's why you will when you see the code of iterator, you will see that we are putting the iterator class as a private nested class inside the whatever data structure we are making, that data structure class. So class linked list is a there public linked list class. inside that linked list class, we are putting a class, whole class, in a composition kind of way, and we are saying that this is an iterator. Let's say iterator, linked list iterator or list iterator. Okay.
Sir, one last question
Yeah.
about the code that you started off with, that supervised learning and all that.
Oh, acha.
Where to get that code, sir?
Sorry, where?
Where to get this code, sir?
I think I posted this code on Discourse, but whatever I discuss in the session, most of them I write, I mean, before the session or something on the run.
Sir,
So,
may I make a request, humble request, sir? If you can
Yeah.
please agree to it. So if you paste this in codefile.io and share the link in the chat, we can have it immediately.
okay, fine. Or let's not do it like that, because then many students will not get it. So let me, why don't I put it on Discourse now? You can refer to Discourse, right?
Okay, sir. Now, I mean, like, but then we could have it instantly, sir, right now. I mean, you can always do both if it's not a problem, sir. I'm sorry to be a pest, but
Okay, fine. Then I think I will just paste it also. That would be easy. Because there are some rules for me as well. I don't want to do anything now. You just copy it from this chat, no? That also is fine, I think. Once you paste it on your editor, it will anyway go properly.
I think somebody has already pasted. One second. Yeah. Thank you.
I think I have posted it on Discourse, na? There also. That's why I was saying.
Yes, sir. I posted the Discord link.
Uh,
Yeah,
Pasted
sir.
link.
Got the Discourse link. Thank you so much.
yeah. Chalo. Okay, fine then. Thank you all. And this
Thank you.
Saturday session, I think Kubra will take. Fine. So
You
we
want
will
to
meet.
meet this Saturday
Okay,
session?
sir. Thank you.
No, I am taking Monday, right? So Kubra will take Saturday, and maybe next Saturday or next Monday, I don't know. One of them I will take.
Okay, sir. Thank you. Good night.
Sure. What is sir's name? Okay. It's kind of too late to discuss that now. Yeah. So my name is Bhaskar Banerjee. Okay.
Thank you, sir.
Yeah.
Thank you.
Chalo.
Sir, just 1 second, please hold on. I haven't copied the code.
Okay. I'm there. No problem.
1 second, sir.
Bhaskar, sir, I have one question.
Yeah.
Okay. I did Java 2. Okay. I was long back. Okay.
Okay. Yeah.
Okay. Now
So
in
that
C
is
Sharp,
great.
you can.
That is great. So we can discuss the interface concept properly, because Java 2 and now, so you would be able to feel it properly if you remember anything from
No,
the
I remember, sir.
Yeah.
Thing is, I'm right now in C Sharp 9 or something like that. .NET Core.
Yeah.
Okay. Here in C Sharp, see, I have not gone detail into Java. Okay. Not
Yeah.
yet. I'm still reading the book.
Okay. May I know which book you are reading? Oracle.
I began. No, not the Oracle one. It's one of those three mentioned books. Okay.
Oh, I think I understood. Okay. I think that Joshua Stropp one.
Not Joshua. It is the Herbert Schultz.
Oh, Herbert Schultz. Okay. Got it.
Okay, so that's what I'm trying out right now.
Okay.
You're going to stop the live streaming. Great.
Yeah. Do you want it to be on the stream? Will it be helpful for them? Okay.
No,
Okay.
sir,
Let it
it's
be
general
on the stream. Let it be on the stream. No problem. Okay. Go ahead. Ask.
So in C Sharp, we have the same problem. We cannot, inherit from multiple classes, but we can inherit from one class and multiple interfaces.
Okay.
But in C Sharp, we have something called explicit. Okay, we can actually put explicit declarations. Okay.
Okay.
So we say that this method came from this particular interface. This method was implemented from this particular interface. So we can do all those kind of things.
Yeah, okay, fine. But then that means you are resolving the issue over there.
Manisa?
What I mean is that when you are mentioning, you are using some explicit feature provided by.
Yes, statically we are resolving.
Correct. So that's what I mean. So, but in Java, it does not have anything like that, where you are statically mentioning that this is the version that I'm trying to refer to out of these 4 interfaces with the same method body. I am meaning this one should work this way, this one should work, or explicitly mentioning. That's Java does not allow that, right? So, how should I put it? The philosophy.
No, sir, not. I'm just finding out how to live with this.
I'm just telling that how to
situation.
live with that. I'm just telling you that only. See, these are philosophical or motivational. Let's say what led to the
Yes,
idea of.
more motivational.
Correct.
Yes.
So why is the programming language designed in this fashion? Why it is not designed in the other way? So, for example, in C++, you write there is some other technique used for dealing with this diamond problem. So, what I mean is the motivation is Java.
Jack the Ripper.
What I mean is
I
that.
apologize, sir.
No problem. So the thing behind it is Java is very, very sensitive about any mistake that the programmer might do. As long as you are mentioning explicitly, I have not used C# in coding. I mean, I have used very little Net Framework, a little bit here and there, but not that much. So as you said, I'm just referring to that and saying, so, and pardon me for any mistake that I commit while explaining this related to the C# part. But let us say if you are statically mentioning something, then that is the programmer's duty, as far as I understand. So if you make a mistake while mentioning that, okay, there are 10 interfaces and each of these interfaces are referring to and are providing a method implementation into a class, let's say, and then maybe you are calling you're calling that function which is common, and somehow you forgot to mention, you mentioned 8 out of 10, you mentioned 8 pairs, that which one is what, where I am calling which one, but 2 you forgot somehow, or you did not refer to, or something happened. So then there would be a trouble, because compiler would not understand that out of those 2 things. So what I'm trying to say over here is Java is very sensitive with respect to the error that a programmer can commit. I can give you another small example, and this is very common example given in any Java course. I'm giving you this so that you understand that Java is so much, how should I say, paranoid, stuff like that, in terms of security. So you see that in C++ or in other languages as well, it is given to the programmer, the responsibility of freeing memory is given to the programmer. So as like here we are defining new keyword and then creating a memory in the heap. In C++, when you write, you use the delete keyword to remove dynamically allocated memory from the heap. If you do not do that, then that is a bad programming practice, but and that would lead to something called memory leak. So since you have already worked in programming, you must have known about all this. So those things happen. But in Java, since it is paranoid, it does not allow the programmer to work with any dynamic type. It will say that, okay, you do the creation, I am the responsible for destruction. So if you learn C, C#, C++, all these courses, there is a concept of destructors, constructors and destructors. But in Java, there is no destructor. Why? Because the destruction is taken care of by garbage collector, which is Java's internal system. And garbage collector is such a system which you cannot call, you cannot do anything. There is a syntax, there is a line of code to call Java's garbage collector, but many people don't know that is not a call, that is a request. You cannot.
So that's a finalizer. I remember it was there long time back.
What was there?
A finalizer. A finalizer.
That's what I'm saying. That,
so in C#, what we do is we call it's not exactly a destructor. Okay, it is. It looks like a destructor, but it has a tilde symbol, and then we suppress the
That's what
garbage
that's
collector.
what a destructor is, right? With a tilde symbol.
Yeah, but in this case, we tell the GC to
Yeah, GC
you know,
dot
call
collect
it.
garbage. Yeah,
Like in C#, destructors are automatically called as soon as you.
yeah. That's what
So,
I'm saying.
is there destructors in Java?
No. There is no destructors in Java. The reference is taken care of by. No.
Tilt symbol is there?
No. That's what I'm trying to say.
Finalizers?
Nothing. Everything is taken care by Java garbage collector. So this is the thing that I wanted to put forward, that the idea is Java is very paranoid about mistakes that can be done by the programmer. And therefore, this is the reason before the advent of Python, 90% of code base was primarily in Java, because it is so secured, and once you write a code which is running in Java, it is very difficult to crash that, because it was very secured and very protected. And that's why most of the web was developed with Java servlets and Java applets. So the language of internet was Java and HTML. After that, this JavaScript came and Node.js came, Python came. This came later, but Java was the prevalent language used for web programming. The reason for that is the security provided by Java. So it is very paranoid in the mistakes that a programmer can do, and therefore it will prevent you to do anything. Most of the things which is also allowed in other languages, Java will have many rules to prevent you to make those mistakes. So, and actually that might be very overwhelming and boring to learn now, but that also makes you understand the internal software design concepts or the security concepts in a much more detailed way, which I think one of the student was Neha, I think, was asking, why should I learn Java in order to do machine learning? So I could not.
Sir, actually, Java is used by most of enterprises.
Obviously,
lots
correct.
of them.
Correct,
Lots of them can't port their code. Okay, it's Java.
Yeah, but that's the point. That is obviously required. But what's more important is, while learning this language, or at least the course that we are trying to, let's say, do over here, our motivation is not to discuss Java syntax. You, honestly speaking, you go on YouTube, you will learn the syntax in much more shorter time. 4 hours lecture, you will get whole Java syntax and everything. But the point is not that. The point is the programming oriented ideas, that how to reflect a real world concept into in terms of object oriented programming paradigms in a real world program. What are the pitfalls while doing that? How should you do it? So that's the idea that we want to discuss in this course, and at least that's how I want to give the sessions, and that's why I kind of discuss these philosophical ideas. So that is very, very important, and what many people don't understand is they would require this, at least this will set the groundwork for something called software design, as you most probably would be aware of it because you are done all these things. But for others as well, for system design, software design, all these ideas would be required when you are finally making an enterprise level software later on. Maybe that software is working on a data science related project, but at the end of the day, when you are writing something that has to take care of also the systems internals and the software oriented ideas, when you are making that particular product, even though it is a anything machine learning related product, but at the end of the day, it is a software. So you have to take care of these ideas. So the system design ideas and all those upper level ideas, those are finally, let's say, the groundwork of them are based upon these subtle security issues and these ideas that, okay, this happens, that happens. So I would say that learning Java is not the point here. This course is more towards setting up the groundwork for having a proper software design idea in your head, so that you can write whatever software you are writing with respect to Java, with respect to web design or data science or whatever. That should make sense.
I think brilliantly explained. It's fine, sir. The only problem is that this Java looks very identical to C#. Okay.
So you are facing difficulty.
Kahin mistake na ban jaye.
Okay.
That's my issue, sir.
Hopefully that would not be. In fact, you will be feeling happy later on, and it would be easier for you to understand with respect to the other students. because you have a little bit of idea of the skeleton of this subject.